Something's going wrong in the neighborhood. Why do we see further than we should? All around us, people unaware, lighting when to see without a care. There simply is no curve inside, and you know we don't spin all day and night. It seems they want our minds flooded with lies. If you want to bust the globe, I know these guys. Who you gonna call? Who you gonna call? Who you gonna call? Who you gonna call?
Who you gon' call when the horizon flattens out? Go ahead, call them up, see what that's about. We can go around in circles trying to find us out, but if you're looking for the truth, you got to find it out. NASA can't go to space, so we hit the roof. Get it? Hit the roof. And it all came to light with 200 proofs. Now I'm just really sick of people lying to me. So when I tell the truth, don't come crying to me. Pick up the phone, get on the line with me. Line with me. Who you gon' call? Who you gon' call? Who you gonna call?
And welcome everybody to Globebusters Flat Earth, a closer look at perspective and angular resolution. I am your host, Bob Xanadude60, and we are back with another great show. Yes, that's right, Jaron, another great show today, and hope you're going to like it. Today we're going to take a little bit closer look at angular resolution issues and perspective and atmospheric things and all the things that everybody's been talking about that makes this a very hot topic. So before we get to that, let me go ahead and introduce my posse here. First up, we have Jaron from Jeranism. How you doing today, Jaron?
Doing great, Bob. Yourself?
Not too shabby. Can't complain.
Awesome.
It's been a scorcher. Like we've had like 300 or 400 degree plus days in Denver. It's just awful lately.
Yeah, same over here. It's been fairly miserable, but today's not too bad. It's nice today.
Well, that's not too bad. That's good. Okay. All right. And next up, we have John the Morgile. How you doing today, John?
Doing awesome. Thanks so much for asking. Glad to be here.
Okay. Glad to have you here. Excellent. And today, hopefully back with less screen sharing issues. We tested them and we think we found the problem. Is Iru Landucci. How you doing today, Iru?
How you doing, Bob? How you doing, people? Yeah, we figured it out. I mean, Jaden, everybody knows right now who is sabotage the screenplay. Shh. Shh, the earth is flat.
Right,
so hello everyone, and I hope we have a great show.
Yep, absolutely. I'm pretty sure we will. I have, like I said, we have some great guests today and a lot of nifty stuff to discuss. So, all right, next up is a flat earther that several of you may be familiar with from Nathan Oakley's Flat Earth Debates channel. He is a relentless researcher. He goes out almost daily, it seems like, with his camera, taking some pictures of far off distant objects from the Isle of Man to windmills and all kinds of other structures, and then does perspective comparisons and specifically, being very critical on atmospheric conditions and kind of explaining why we see what we do. So with that, we have Ranty Flat Earth with us today. How you doing today, Ranty?
Good evening, Bob. Nice to be here. How are you?
Doing really good. Doing really good. So I'm glad you're going to have a whole bunch of stuff to share with us today.
There's a few bits and bobs here.
Yep, absolutely. Cool. And also his partner in crime from the Flat Earth Debates channel, we have Anthony Riley from the Sleeping Warrior channel. How you doing today, Tony?
Doing glorious in this lovely, lovely summer in the Lake District. Currently, I'm up at St. Bees in Whitehaven, and the weather's just sensational. This is the short period we get called summer. It'll be gone by Friday, so we're enjoying it.
Oh, that's awesome. What's the temperature looking like there, roughly?
Well, it was 34 midway through the afternoon today, and it's cooling down now to about 27. So the dogs are able to go out and actually go for a walk on the tarmac. So they're out currently. They're out having a walk in the sunset, and it's lovely. So we're just enjoying a bit of time away, rest and recuperation.
Beautiful. Okay, good deal. All right. So then, yeah, we're going to get to the main subject matter here shortly. There's just a few things that I want to cover beforehand. Oh, wait a second. Did I forget somebody? No, I didn't forget John. Geez, God, I am just losing it today. I thought I forgot about John.
I was just going to say, for those who use Fahrenheit, that's about 80 degrees at the low end and 94 at the high end. So you call that summer? Yeah, you pussy. No, I'm kidding.
Yeah, really, that's not summer temperatures. That's a spring day here.
And John, by that you mean normal people, right? Who do
Right.
Fahrenheit and inches and okay, just make sure.
Right. Yeah, absolutely. Those normal people out there.
That's right.
Yeah.
The UK, those guys are kind of strange. All right. So anyway, all kinds of fun stuff that has happened this week. I guess, Jaron, we can talk a little bit about the second Salton Sea experiment that apparently nothing happened. I didn't catch. Well, I didn't catch any of it actually. I saw the replay, but you said it wasn't worth watching. So what happened?
Yeah, you saved yourself 6 hours.
Yeah.
It just seems like they got down there. I don't think that they were fully ready for everything, and I think it was windy, so they just had some problems with it. I've kind of learned that anytime you're going to go out and do an experiment at this point, you should do a pre-test where you do it exactly the same so that you have everything accounted for. But they just had some mishaps. I think they lost a balloon, and I think they were tired come morning. They were supposed to be doing the test at like midnight, and it was like 4 a.m. until they were even getting close to being able to look at something. And then they said the visibility wasn't good. So that was basically the gist of the entire 6 hours. So you can watch it if you want, but there's nothing that comes out of it.
Yeah, that's disappointing. But oh well.
Yeah, a bunch of shills.
Myself included, I know.
All right. So, okay. Well, at least, like I said, at least I didn't waste any time watching that. So that's good. But I'm sure that they will get it together because, contrary to, popular belief, getting experiments to cooperate both weather-wise, equipment-wise, personnel-wise, and for everything to come together is really a lot more difficult than it might seem. Yeah, and I think that the proof of that comes with just showing some of the trials and tribulations that you've gone through, that FE Core has gone through. Sometimes things just don't want to pull together for you at all.
Yeah, I'm sure that people out there too know that because of how many times somebody's tried to do something and then it didn't come out right. So those are the things that don't show up on YouTube usually.
Yeah, exactly. But we're being transparent, boring as it can be sometimes. We just got
good things at the start of that, or things that I brought up. I brought up the disclaimer that's on the bottom of the Over the Poles flight website. Have you seen that yet, Bob?
The disclaimer. Oh yeah, actually, we were going to talk about that today. I've got that.
Amazing that. I make my Spanish version, and a lot of comment of people that they couldn't believe, because 1 month later in the radio talk that I was invited, I'm the host of the show. He asked me for the flight, the Chile or Argentina flight to Sydney, and I said, okay, we don't have like free permission on the plane to make our own experiments, so we don't clearly determine what is going on. And then I saw that this disclaimer, and I said, man, that is like a premonition, I mean, amazing. That code of conduct is it must be a warning for the people that is in the middle of what's going on here. That is a nice path to follow.
Yeah. Well, and a couple people did videos on this. Celebrate Truth did one, and so did Taboo Conspiracy. And Taboo Conspiracy, went on to elaborate even more how this thing was doomed from the get-go, and that it appears to be a scam. And that is that what he found is, according to the federal air regulations that are in effect for Antarctica, apparently there are limits to which that particular model of aircraft can go from any major airport, and I think it's something like 15 or 1600 miles, something like that. And which means that there's no way that they can get anywhere near the South Pole, or the Edmondson Scott Station. So all of this has been, and of course the FAA could waive those regulations, but I seriously doubt that they are, because we know that they're not going to go down there. But in case you guys have not heard about this, what everybody is talking about is this flight around the globe, the Polar Explorer flight. And it's at this website, overthepoles2018.com. And you can go there and look at it. And what we're looking at specifically here is the code of conduct that shows up down here. And it says Polar Explorer, is a celebration of commercial aviation and a homage to the achievements of Pan American Airways. The spirit of this flight is one of adventure, friendship, and shared goal of establishing a new aviation speed record. Yeah, right. Although the flight is open to all who wish to join in, it has come to our attention that some have expressed interest in using this flight to attempt to disprove or discredit scientific fact. You got that right, Slim. As the safety and the comfort of all passengers is our primary concern, we will not permit any scientific or experimental equipment of any kind on board the aircraft. All right, so guys, that pretty much says it all. And I think I had mentioned this a few weeks ago, because I had gotten an email, I think from MGTV of all people, who sent me the information showing that indeed they were not going to allow any experiment, any test equipment, any experimentation whatsoever on this flight. So obviously the question then becomes, well, then what is the point of even going on the flight? Unless, of course, you want to have your haircut during this time, or have a caviar expert on board with you. Just ridiculous things altogether. And of course, it also brings up the question, well, what about Greater Sapien, right? Greater Sapien basically crowdfunded from all of his viewers. And by the way, this has been known for quite some time, because like I said, I mentioned this well over a month ago on Globebusters when I first found out about it. And apparently it's been in this, on the web page itself. So either Greater Sapien read this and is aware of it and is going to claim that, he went around the world anyway, or, he didn't do his research, which of course is also pretty normal, I think, for him, and is going to go take this flight, with $20,000 of his subscribers' hard-earned money, and he's going to come back with no proof whatsoever other than what they tell him. And at that, I'm just going to have to laugh. So you got to wonder, what is he going to do, when he gets back from this trip? So I don't know. I really don't know.
So I'm a little bit lost here. So the flight is supposed to go across the Antarctic. Is that right?
Yeah, it's supposed to go all the way around the world. It's a pole to pole excursion.
Yeah, in fact, supposedly when you see, when you look at in the web page, they're talking about they are going to go literally across the Antarctic for the middle, for the supposedly geographical south and the geographical north, which everybody knows that is impossible because you don't have the permission of the military bases to do that. So I don't think in this case they're going to have the supposedly permission. And in fact, I don't know how many of you saw the video about the Captain Marcelo Diaz, which is an Argentina pilot who made the only one flight, transpolar flight from Aerolíneas Argentina. that he talks. He's filming on the cabin, and he talks with this guy, which is the same guy that is going to film the supposedly Over the Pole 2010. Is the same guy. He's a blogger and videographer, doing all this, filming this kind of flight, the special flight. And this captain talks about that they have one of the most important issues with flying near the poles, not for the middle, near the coast of the South Pole or the North Pole, is you're going to have the freezing point of the fuel. So the condition up there doesn't allow you to fly in these really low temperatures. And the other issue is that you don't have the permission of the military bases. So I don't know how he's going to supposedly doing this flight.
Well, not to mention the Antarctic Treaty has some provisions against that sort of thing, I think.
They do.
So, yeah, it smells funny to me.
Yeah.
Yeah, exactly.
Yeah, it really is. And of course, it's interesting because when you go further into the fine print, as Taboo Conspiracy does, he finds out that, they can change the route at any time. They say, well, if we don't make it, we'll give you back your money unless we can come up with an alternate route. Now, they're not saying alternate route to what, they're just saying alternate route. So basically, what they're going to do is they're going to say, oh, well, safety conditions prohibit us from doing this or whatever, or this country won't allow us to do it. So we're just going to go almost to the South Pole, but not really, and we're going to skirt it. This would be my guess as to what they're going to do, because it's all set up in the fine print, essentially, which is pretty amazing. So you have that. You have the fact that the applicable flight regulations do not even allow that particular type of aircraft to be even any further away than, like, I believe 1,800 miles. You have the fact that for whatever reason, they're claiming for safety reasons, right? For safety reasons, we're not going to allow anybody to bring any scientific equipment on there. Of course, before that, they preface it with, oh yeah, it's come to our attention that people are trying to, debunk a proven scientific fact, right? That's nonsense, because the type of equipment that would be taken on there is stuff that we have already taken on domestic flights, for some of our own tests: the gyroscopes, MEMS accelerometers, fiber optic gyroscopes, GPS receivers, spirit levels, whatever. But no, all of those things have been completely kiboshed by the company that's running this. Under the claims of, well, we can't risk anybody's safety over this. And plus, we don't want anybody to try and debunk our already proven scientific, axioms. Which, like I said, if that doesn't scream, we are out to screw you people over, then I don't know. I don't know what to say. I mean, how obvious does it have to be?
And we're expected to believe that, in light of the fact that this massive globe Earth conspiracy has been, sort of perpetuated over the last century at the very least, with everything from the Antarctic Treaty to NASA to just, covering up Richard Byrd's findings, all kinds of stuff. I mean, are we really expected to believe that they wouldn't have other little, things in place where they could present them as evidence for the globe and just, maybe pay off a handful of people? And Greater Sapien certainly doesn't have any sort of credibility as far as being an objective scientific person, as far as I'm concerned, just based on the work of his that I've seen. He's a scientism sort of person. He's going to go with the globe Earth narrative no matter what. So anything coming from him or coming from a flight where they're supposedly going around the Antarctic, not allowing people to bring scientific equipment, to me is just, it's not even, nothing that I would hold too much weight on, unless perhaps they come back with something that doesn't work on the globe. But I don't think that would ever happen, not in a million years.
Yeah, I totally agree. And it's funny because I'm already seeing in the chat comments, the Globe Earth trolls are saying, oh, they don't want any idiot flat earthers to disturb the other passengers on the flight. It's like, really? Are you serious? This is a one-time historic flight that, nobody's ever done before, right? And so you're saying that it's because they don't want to disturb the other passengers, rather than you don't think that a good enough reason is to actually prove where these people claim they are going, especially with all the nonsense that has gone on around the South Pole. I mean, this is a typical globe Earth troll idiot response. Oh, well, they just don't want anybody to be disturbed. That's about as dumb as, well, we don't want anybody to disprove our scientism, that says that, the Earth is a globe, which is exactly what this company said. So it's like, wow. The Globers are really, really scraping the bottom of the barrel. And like I said, I can hardly wait to see exactly how Greater Sapien is going to handle this. Is he going to punt his ticket and refund his money, or is he going to just go ahead and take this this ride on everybody else's nickel, and where ultimately all he's going to be able to do is take their word for where they're telling them they are, right? So it just absolutely floors me that that this is even happening like this. So
Yeah, in fact, in the first flight that Pan Am make, because when you go to the webpage over the Pulse 2018, you have two videos that this company proposed to see. And the first video is about the same kind of flight that Pan Am made 20, 30 years ago. And one of the invited special guests that they have is the grandson of Richard Byrd, for example, because they have like this kind of advertising situation that, hey, we have this special guest who is going to corroborate everything because he is the grandson of Richard Byrd, so he know what we are doing and things like that. It's just the typical situation of when you see something that they want to promote. So they interview the passengers after the flight. They have even product selling on the flight. It's like Disneyland flight. There is nothing to do with science and things like that. And the second video is about a flight from the South Pole, showing some picture and some landscape, and that video is provided by NASA. So you have that. In fact, if you play the first video about the Pan Am, that video open with the historical image of the Earth from supposedly the space that Apollo 17 take it, and close with the same image. So it's all pre-programming mind control situation. That is my point of view, of course.
Well, I think it's a shared point of view and a very valid one. This is just all a ruse, every bit of it. And it's funny that when they announced this kind of trip in the first place, that they come up and say, oh, well, it's just come to our attention that people are going to actually be trying to verify where we're going, right? So whatever.
Yeah.
So yep. So it's going to be a fraud. So anybody that comes back and has been on that flight and says, yeah, for sure, we went to Antarctica. You know how I know? Because they told us so, and we flew over some ice. So, that was definitely Antarctica. And, it's never going to happen.
I don't know if you are aware, there was a news 2-3 weeks ago that Airbus, for example, a company from, I think it was the Saudi company, proposed to use virtual windows for the planes, for the new planes.
Yes.
So you're gonna have to put all this together, and I don't talking about this flight especially, but in the future they're going to control everything you saw from inside of a plane, like they did or like they do right now when you put the screen, or the employers of the plane comes and say, okay, close your windows for the next 5 hours because the people want to sleep, and you must have all these kind of things in mind, because they're going to do these kind of situations to control what is going on outside from inside.
And I'm just going to throw something out there. Just this last week, Flat Earth Crush YouTube channel put out a video with something that's really interesting to me, where they came out with a new so-called working flat Earth model. And basically what it is, they take an AE sort of projection and they put Egypt more or less right in the center as opposed to either one of the poles, which is something that I thought was an interesting way to look at the flat Earth model several times, because we know that Egypt, Cairo is the geographical center of all land masses on the world and such. And basically in this new model he's proposing, he's got two poles like you see there on the right, northern and southern poles, and you've got the sun essentially making opposite rings around either pole depending on the season. Summer north, summer winter, winter north. Ugh. And I just thought it was really interesting because this purports that there may actually be a continental landmass of Antarctica. Although I do see some problems with this idea, and I always have when I was looking at that sort of thing a while back, mainly because there's just the absence of flights and shipping routes in the southern hemisphere altogether. But it is an interesting way to look at this, and let's just say this flight is 100% legit, which I have my reservations on that. In this sort of model, that'd be 100% doable. So the existence of an Antarctic continental landmass, to me, doesn't do anything against the flat Earth theory, as it were. It just goes to show that we really don't have a firm understanding as to what's going on in the heavens and what the actual system of the sun and the stars entails.
Yeah. Well, and also I will say, about this, when this first came out, I mean, I looked at it and it's like, wow, that's kind of interesting, because it does seem to solve some of the anomalies. And of course, then, we all took a look at it in FE Core as well. And, we've kind of covered up some other issues that go along with this map. And I'm not really prepared to elaborate on it just yet, but I do know that several people in FE Core were looking at it, and they like the original concept, but like most maps, there are some other issues. Now, whether or not they can be resolved through explanations of certain optical properties or whatnot, like we're attempting to do with the AE map, remains to be seen yet. But we have also identified a few problems with it, and I'm sure that we will definitely be elaborating on that when we are ready to do so. But I don't want to go off half-cocked and just start, talking crap about it when I don't have all the facts.
Yeah, sure. No, I was just throwing that out there because I had watched that video a couple days ago, and I like the concept as well. But you're right. I mean, it does introduce some other problems. But if something like that's the case, I guess my main point is that, again, the existence of an Antarctic singular landmass as opposed to like an Antarctic circumference ice wall is totally doable on a flat Earth, and them flying across it wouldn't change my opinions at all. But yeah.
Yep. All right. So yeah, that's interesting that you brought that up, John, because like I said, Flat Earth Crush has been working on this for a while, and I respect his work on it for sure. But like everything, there do appear to be issues, and of course, this is why we, pass this stuff around in the community to see if we can get it debunked or modified or in a workable state or whatever before it's ever presented as something that is as plausible. And it still may be, like I said, it may be very plausible, but with a few tweaks here and there. So we'll just have to wait and see.
And something that I want to share about this topic. Yesterday, I talking with a friend of mine that he is drone pilot, and he have a school about that, and he is in touch with a few professional pilots. And one of these professional pilot talks that a few years ago, I mean a few decades ago, you can fly from Buenos Aires to New York in around 8 hours. In fact, in our days, American Airlines, they can fly, in 10 hours and 40 minutes. But I just dropped this on the table because when you see that video, that transpolar video with the Captain Marcelo Diaz, he talks about to fly from Chile to Sydney directly. They took about 16 and 45 minutes just flight, not block time, not when you ascending and descending the plane. So in total, they took about 18 hours. And if you take that into account, I mean, you fly from Argentina to New York in 9 hours, for example, you have the double to go to Australia. Of course, if you check, now flights from Chile or from Argentina, if you check, if you looking for flight now, you're gonna find like 15 hours to 16 hours directly flight, direct flight from Argentina to Chile. But we must be taking into account the jet stream. The only one of the few flights that the pilot know that they took random path is the Chile or Argentina flight to Sydney. That is one of the only few flights that the pilot took random path flight, because the conditions and the winds and everything of that reduce the pre-planning flights. This is not my opinion. I mean, this is you can see it and hear it directly from the pilot in the cabin. So nothing. I mean, if you take into account the jet streams and the winds and another condition that we don't know because we are not a pilot, I think there is no issue to take in 15 hours in the model of the Gleason map. That is my opinion.
Yeah. Okay. Fair enough. All right. So I'm trying to figure out where to go here. Okay. So yeah, what I'm showing now, we're going to actually cover here in a little bit when we get back to Ranty. And sorry for being a little bit disorganized here, guys. I'm trying to go through all my tabs. A couple other things that I wanted to cover before we get into the main topic is, first of all, hat tip to Will, The Truth is Stranger Than Fiction, because he was apparently working with another graphic artist. And it's interesting, they started, this graphic artist found that there was certain patterns, in addition to the replicated cloud stamps, that we've all seen, that have been taking place in all the models of the globes going all the way back, between 2002 and 2017. Did any of you guys see this at all? This is pretty amazing.
Yeah, I saw it. Nice video.
Yeah, it's a great video. So basically what they identified is there is this particular cloud pattern that appears over and over and over and over and over again, all over all these different globes. Even to the point where I'm sure you guys all remember the eclipse video that we all saw. And here's some more examples of it. Here it is in this area. And they all seem to take place in relatively the same region, but you can see the same cloud pattern pops up over and over and over again. Lo and behold, here we have it again over this. I'm sure you guys remember this, the alleged umbra of an eclipse. And here we've got this same cloud pattern again. So, I mean, it's amazing how it just keeps going over and over and over again. We keep busting them. When are they going to, either do something original or, actually try and take a real picture instead of just feeding us CGI crap constantly with the same cloud patterns, that's spanning over 10 years. It's spanning over 15 years, excuse me. So.
Yeah. I don't know why they do this kind of thing, because me as an artist, I mean, you can replicate and you can create any map of clouds to mapping on the sphere. So I don't know if they have some copyright issues in the same NASA, because it's I can understand why they do this. They don't have the technically speaking, they don't need to do this kind of bullshit.
No, you're absolutely right. we've got how many tens of thousands of satellites up there. We have little junker satellites that go around and scoop up all the space crap that's up there, right? And they all supposedly have cameras on them, and yet we can't get a live feed, if our life depended on it. And of course, the rhetoric that we get back from the Globers is, well, the NASA isn't into responding to what you flat earthers demand. It's like, no, it's not just us flat earthers. This accusation that has been going on about NASA being a fraud, it goes all the way back, to the Apollo missions, and it's just absurd that NASA seemingly does not want to vindicate themselves, whatsoever. I don't know if you guys saw this or not, but this was originally put up by Haunted House, and he had mirrored it from another page, which I found. But so hat tip to Jonathan Haunted House on this. But I put up this week on Globebusters a video called "Was It Only a Paper Moon?" And I watched this, and I have seen pretty much all of the debunking ones. I had never seen this one before, but this one, in my opinion, and I'm sure you guys have probably seen this, is hands down the best one that I have seen overall. And it's basically an open letter that this journalist makes, and he goes and he investigates everything there is to investigate about the Apollo. He goes to the museums, he takes measurements. We find out so many additional frauds that are going on with NASA that it's like, these questions have been asked for 50 years now, right? 50 years, and NASA has not been forthcoming with any of these answers. So, did any of you get a chance to catch this? If so, what'd you think of it?
Yeah, I started watching it. I actually fell asleep, but again, I do that a lot. I was really interested in it. I thought it was great, but at some point I did fall asleep.
Oops,
Yeah,
sorry.
it was really well done, and I was surprised to see that I had never even heard of it, being that it was done quite a while back, it seems.
Yeah, I think it's, I don't know if it's from the 90s. It says 1997, but I don't think that's right, because this guy, when he's talking about it, he's talking about Bill Casing's video coming out, and then the other guy, the photographic analysis, I forgot his, Ralph Renee was one, and then another one. So it almost seems like this was made in the 70s, and it certainly seems to have that video quality.
Yes, and I saw it, and it's one of the most things that I like it was when they start to measure how the astronaut live inside the supposedly lunar module, and
Yeah. How did they get
Yeah,
outside the
supposedly-
limb?
exactly.
Couldn't
That
even
was
fit in
amazing.
there and open the door. Right, yeah.
Yeah, exactly. That was amazing.
Because of course the door opens in towards the interior where they're already squished in there, can barely even move with all their astronaut gear on. But then the door opens inward, which I don't know. It just doesn't make any sense to me why they would design it as such.
I mean, 3 days inside of that mini capsule. I mean, way they poo, and at that, with that technology, how they change, how they put the suit. I don't know. I'm just asking.
Yeah. Well, and he also points out some other obvious things that, a lot of people I think have missed. For example, like I said, they only had, like 2 feet of clearance. It's barely the size of two phone booths in there. And then he takes the measurements of all the backpacks and shows where they're standing, and then shows the fact that the door is opening inwards. And with all that taken into consideration, it's simply impossible that they could have even opened the door to get out of the limb. And, and beyond that, he also points out certain things that, we've looked at a million times, like the footprint on the moon, where, people have said, well, it doesn't match the boot that the astronauts were wearing. And of course, the response from the Globers to that is, well, that's because he was wearing an overshoe type of thing over the boot. Well, that's all fine and dandy. But then this guy points out on that, it's like, look, if the moon is getting up to, plus 250 and beyond degrees, then where is the moisture coming from that is allowing these boot prints to actually clump and hold their shape as perfectly as they do? It's just things you look at and it's like, oh man, that's really a good question, because if it was just dust, it certainly would not clump like that and hold that shape so perfectly.
Gravity.
Yeah.
Go ahead.
gravity.
Yeah, I was gonna say one of the big things too is the intersecting shadows, because of course NASA claims that they didn't bring any sort of lighting to the moon, which makes sense. But then you have these shadows which would apparently intersect, and that just can't happen due to sunlight. And so it's just amazing to me how arrogant and kind of stupid NASA was about this, but people bought it. But I guess they didn't ever imagine that, at some point people would go back and actually look at their so-called evidence of being on the moon skeptically. And for decades that was the case, it seems, although maybe not so much in light of documentaries like this. But yeah, those intersecting shadows was a real big thing for me anyway, years ago, way before I ever landed on flat Earth, at least understanding that the moon landing was a hoax, because they're obviously here on Earth with stage lighting and certainly not on the moon.
Yeah, absolutely. And another thing, yet another thing that was pointed out in this is he's doing a very close analysis of what's going on with the dust that's being kicked up from the tires. And it's very clear that the wave pattern that they're going up, they are going up and they are hitting an atmosphere. Because if they were truly in 1/6 gravity and in a vacuum, that sand pattern would have dispersed in an arc, almost a perfect arc going across. But instead, when it pops up, and this, like I said, this is not a good resolution, but you can see it. You can see these things actually coming up in waves, and they are hitting something, which is, obviously an atmosphere, right? Because this would never happen in a vacuum state with 1/6 gravity. This stuff is hardly even kicking up at all. And like I said, it's very obvious that it is hitting an atmosphere. So, I mean, this thing is an absolute gold mine. If you have not seen it, it is on the Globebusters main channel. Check it out. This is one of those, in my opinion, this is one of the best all-time debunking movies ever. And, it comes from this guy's personal journey dealing directly with the NASA people. And he just shows it all to be completely fraudulent from the get-go. And I don't think the Globers are going to have any rebuttals to this.
And one of the big things I gleaned as well, like you mentioned, he was like buddies with all these NASA guys and even I think a couple astronauts. And he's looking at this stuff going, hey, what's up with this and what's up with that? I really don't think you went to the moon. And instead of taking any of his stuff seriously or acknowledging that he had a good point, they basically threatened him, ad hominemed him, and told him, if you keep this up, just go to hell, basically. And the astronauts and NASA people aren't interested in science. They're merely interested in perpetuating the Ballers narrative. That's it.
Yeah. And he also mysteriously died, supposedly of cancer, a year after this was made. And he was a relatively young man. And I'm not saying that doesn't happen, but it seems like, whenever anybody comes out against NASA and it's very damaging, like Gus Grissom or anybody like that, they usually wind up dead, a short time later. And, if NASA had nothing to hide, they would certainly be transparent about all this stuff. But the hoops that this guy had to jump through to even get them to allow him to measure some of these things. And there were some things that were just, even though he was up there on a lift truck, trying to measure things, the curator of the museum said, no, you will not measure that. It's like, why not? What is the problem, So again, the way that they hide things speaks volumes. And the way that they, handle things speaks volumes. And all of it is clear that they are hiding something and they're being deceptive. And, if you can't see that, again, I don't know what to tell you, because, we all have dealt with people that we know are being deceitful, right? And you don't have to really, you can just simply tell it, right? And if NASA was being completely honest about things like this, we would not be getting the reactions that we do. So anyway, fabulous video. If you haven't seen it, by all means, watch it, because it's awesome. All right. Any other comments on this? All right.
Nope.
Okay. I'll take that as a no. All right. One other thing that I wanted to cover, and this is pretty interesting. We have a video here Okay, and um, it was put out by a lady called Fractal Woman. Now, I came across this um, channel, I don't know, a month or so ago, and basically what she does is she's a big Ken Wheeler fan, but you know, Ken Wheeler can use an awful lot of big words, and sometimes it's difficult to understand what he is saying sometimes. And so what she does is she kind of repackages what Ken Wheeler says and puts it in more digestible English, so that you can kind of understand where he's coming from. Well, anyway, she came out with this video, and this particular video um, highlights some footage that of Don Pettit and doing experiments while he was allegedly on the ISS. Of course, we know that's nonsense. He was in some sort of probably a vomit comet or something like that, where they are getting zero G effects. And what's interesting about this is they're doing experiments. He's doing experiments um, on dielectric attraction. Now, if you guys remember, I've talked several times about, you know, the electric universe's model of gravity and how it is actually a static dipole alignment type of phenomenon, right? Well, so what this video is essentially showing is he's taking different materials, sugar and other things like that, sodium chloride, crystalline type things, and he is showing that what's happening is if he puts a slight static electric potential on the bags, then what happens is the crystals in the salt and sugar and other various materials will line up, you know, plus minus, plus minus, plus minus, just like the static dipole effect. And of course, he's describing this, and he is absolutely surprised because this goes against any mainstream expectation. But you know, like I said, you know, it's showing us very clearly that these crystals are all lining up, and they're lining up with the source of a static electric field, essentially. And once they're within that, they just start lining up perfectly, and it acts very much like gravity. And this is exactly how Ken Wheeler described it. This is exactly how Wal Thornhill of the Thunderbolts Project explained it, you know, as far as what's going on. So he goes through this whole thing, and it's absolutely amazing that, you know, all these different materials are actually behaving like this. So this is all fine and dandy, and it's really cool. But then, well, let me go back to a little bit. We were talking earlier this week in FE Core about, you know, what do you suppose is actually keeping the tens of thousands of pounds or tons of water in a rain cloud, right? Why doesn't that just fall to the ground when they're so heavy? And, you know, I don't exactly remember what the mainstream explanation is, but it seems to me that it had something to do. And you guys, if you remember this, correct me if I'm wrong, but it seems to me that the mainstream idea is that there's these updrafts that basically are keeping these small particulates up and up and up until they get large enough to overcome these updrafts, and then they come down as rain or snow, right? Which, of course, really, if you think about that, that is a nonsense and an absolutely absurd explanation, if that's even the right one. But all that aside, you have to ask yourself, what is it that is keeping these tons and tons of water in the clouds? Why aren't they just pulled right down to the ground? And again, it comes back, you know, through some scientific experimentation and proof to electrostatic charge potentials. And so Chris Seeley sent me this video this morning, and I found this, you know, pretty amazing. I'm just going to play it and let you see a little bit of the video. But basically what's happening here is they are putting oil and water and certain other materials under a static charge. And what's happening is we're starting to see like bridges form. Bridges will form across, like from one to another. In other words, there appeared to be this static dipole potential in between the clouds, the static potential of the clouds, that is what is actually holding the tons and tons and tons of water up there, right? This makes a lot more sense. And again, it's demonstrable in a lab. Whereas, you know, when you start thinking about, well, what is it about? Why doesn't gravity pull down these tons and tons of water? yeah, this just makes a whole lot more sense. And again, so here we're starting to get experimental proof, not only from physicists, but from NASA people themselves, whether they're doing it unwittingly or not, that are telling us that, gee, the static potential that is going on everywhere is most likely what is responsible not only for gravity, but for seeming anti-gravitic effect, as far as being able to levitate charge and take it from one container to the next, or hold water up in the air in clouds when it should be falling down, being pulled down by gravity. All of these things are demonstrable, and you can find these demonstrations on YouTube. So again, this is just something else that I found very, very interesting. These videos in and of themselves don't prove anything conclusive other than the concept is very sound. So, Iro, I don't know if you've seen anything like this before or not, but any comments on it from anybody?
It's fascinating, isn't it?
Yeah.
Yes, yes. I am I'm a huge fan of the Thunderbolt project, and I really have a full not full, but a really nice presentation that the time doesn't allow me to present in the UK conference. But it's based. You can explain everything when you trying to replicate with electricity and magnetism, and I think that is the concept of Zeus, the god of the thunder, because this plane was created. That is my opinion, of course, but it was created by the force of electricity and magnetism. In fact, the word magnetism comes from magic, because they don't know how is work the magnetism. I mean, you can prove it, you can play with that. It's like the gravity concept, when the Grace Tyson talks about that. You can measure, you can predict it, but what it is, I don't know. And that is the same, but that is the real concept when you're talking about the electricity and the magnetism, and that is fascinating. And you can explain everything with these two, divine concepts.
Yes, absolutely. So again, this is just something, and of course we were, the guys in FE Core are doing some fabulous work on this, and the more of this stuff that we assimilate and put together, the more ultimately we're going to make a presentation on Globusters about it, and of course in the FE Core videos themselves. But this is just kind of a preview of the kind of things that we're looking at and the kind of answers we're seeking to explain better than the mainstream gravity model, which is nonsense, using electrostatic and electromagnetic energy that, like I said, is demonstrable in everyday life, right? So, pretty cool stuff. So, all right. So, and I think I'll save the rest of that for a little bit later, the other stuff. So, I'm going to go ahead and we're going to talk a little bit to Ranty and Sleeping Warrior. And I guess, Tony, I'll start with you. If you can give us kind of an overview of what the kind of stuff you guys have been going on over on Nathan's channel, the people that you have debated, debunked, and whatnot, and the information that has come out of it, in your work over there.
It all started last summer, at the back end of last summer, and we were away for a short break in the same place that we're at now, coincidentally. And basically what happened was I went up there looking specifically for Blackpool Tower. It was a little bit too far. Angular size resolution stops us from seeing so far, and I realized that I couldn't see it because it was simply too small. They would say it's behind the curve, but I realized it's just that it's too small because it's too far away. But whilst I was where I was, I thought, well, I'll just pan across my horizon and see what I can see, just for keepsake's sake, really. It was more memento, like holiday kind of thing. Wasn't thinking too much flat Earth at the time. And then a few weeks later, maybe 2 months later, Ranty said to me, what did you get that day? And basically, I sent him a copy of it, and he said to me, I think there might be flat Earth proofs in this. And I was like, what are you talking about? So we presented it on Nathan's show, and we had a back and forth. And basically, we were forced into making a composite, which was like a stitch of a load of documents, a load of stills out of the movie that were all put together. And basically, what we're doing at the Lake District, or where I was at the time, I'm looking across the Irish Sea, into towards Ireland. But in between me and Ireland, I've got the island known as the Isle of Man, and it's quite a small island, but it kind of sits equidistant between 3 or 4 different places that are within the Irish Sea. I don't know, maybe it might be a good idea to put a picture on if a screen share, maybe. I don't know.
Sure,
Should I screen?
absolutely.
All right, let me try screen sharing. Then get this there. So you see my screen now, yeah?
Not yet. Yep, there it is. Okay, we got it.
All right, so obviously I realise that not everybody's in the UK, but for those that don't realise where the Isle of Man sits, it sits right in the middle of the Irish Sea, but it's equidistant from the east coast of Ireland, the southern coast of the southern coast of Scotland, and obviously the west coast of north of England, which is where I am currently. I'm sat in this area here, but I'm looking across the Isle of Man, and I'm looking at the horizon. So I got forced into, or Ranty made this composite, which we passed between everybody. And on the composite that we used, we were able to pick out individual features. And one of the most talked about features was this one down here called Mackle Lighthouse. And Gem Panda spotted it. And it became a focal point because it should be behind the curvature of the Earth. And it went on for ages and ages. But I was challenged to buy a couple of the big ballers, that protagonists that do go in, namely Slice Barkane, Mark Taylor. They were saying this is all well and good, but the claim I made at the time for the original video was that the land that's now on screen here, that I affectionately called as floaty land because it appears that it's got a line of sky that goes underneath it, and I didn't know why it was doing this, but nonetheless I called it floaty land in the north. They said, all right, Riley, go and get it from the beach. And I was like, well, it's the back end of winter now. It came out the week before Christmas. I said, you're going to have to give me till summer because like weather over here is not great in winter. Give me till summer. I'll go back and I'll do it. So I went back and I got it. And what I realised when I was laying on my beach on the beach on my belly, I could see this land, and I could also see the land that's here, which is like the mainland of Ireland, of Isle of Man. But the problem that I noticed in the video was that it seemed to be very compressed and squashed. Now, at the time, I didn't even recognize that which I was looking at on screen. So when I went back and got the imagery, I didn't recognize this land that I'm looking at now because it was flattened. Now, there is an argument by the ballers, which would be that the horizon was risen up because of the curvature of the Earth, and that what I'm actually seeing is not flattened land, but I'm seeing the horizon coming in along here, and it's giving me the perception that the land was risen, the horizon was risen. In other words, proof of curvature. But the problem was, the land that was on the right is only 300 feet tall, but I still got this land on the right. And what that does is it locks the horizon to here, because if the horizon had risen on the left-hand side, it means that this would not be visible over on the right-hand side because it's only 300 feet, 200 to 300 feet. So that's the first thing I noticed, that there was this element of squashing. And why that's relevant is when we go to if we go to Google and I type in the word perspective and then go to the images, this is something that we all are aware of, but I've never really seen any evidence that it's true. I've always seen this kind of drawing where everything disappears off into the horizon, and I've noticed that like these horizontal lines here all represent the same gap, but as they get towards the horizon they get squashed, and I'd never really seen proof of this or evidence to suggest it was true, only kind of inferred stuff. But in the back of my mind I'm now thinking, well, for whatever reason this land now appears to be squashed. So I've realized that there's a squashing effect going on, and it seems to be consistent with this perspective idea that things get towards the horizon and squash. But when I went back to the beach and I got it again for the second time, this land should be gone. We shouldn't see this at all. It should be behind 700 feet of curvature. So for me, this was like a cast iron, like flat earth proof, and it's not been debunked to this date. But because I'd been back at that period of time and challenged to go back and get it, at the same time period, there was a baller called Al K that brought out a video that he claimed was debunking something that Del from Beyond the Imaginary Curve did about a mountain called Elsa Craig. And what he did was, I'm looking at 34 miles from here, and I'm looking at like artifacts that are like 2,000 feet tall, and I know how big these things look from where I am at 34. But he got Elsa Craig, which was only 1,100 feet, which is half the height, but he got it from 38 miles away, and he claimed that it was a ball Earth proof. But I took one look at it and I realised that, hang on a sec, there's no way that that should be represented like that on a sphere Earth, because he's getting further distance away from me, but he's getting half a mountain that I had, but he's seeing the whole thing. Now, he made a big deal about whether he could see a lighthouse that was on the beach or not, and obviously he couldn't. But the bottom of his picture was squashed in the same way that I found it on mine. So it dawned on me that there was an issue of perspective that was going on here that wasn't previously declared, like we hadn't spoke about it. So it was the combination of these two things that made me realise that when we go and present evidence for these ballers to scrutiny, to give them scrutiny of and to give scrutiny of, what they always do is they'll give you, you'll put in your distance, and then if you say that you were at 10 feet, somehow it'll end up at 36 feet, and you've just got to accept it. But the point is that this distance in miles in Al Kay's case was 38 miles. And what I realised was that the value that was hidden for Al Kay's observation at 38 miles, and he was literally a foot off the water when he did it, I'm looking at that value and I realised that, hang on a sec, he's showing the whole mountain there, but it's saying that virtually all of it should have been behind the curvature of the Earth. And then I spoke to Adam Meakin at Iron Realm Media, and I said to him, look, I think that something weird's going on here, and I don't think they're taking into account perspective. So I ran it by Nathan. I put it through on Nathan's show, and I wasn't able to articulate myself well enough because even Nathan didn't get what I was saying. But it appeared that when we put in the curve calcs and we get this refracted hidden value, when it comes to applying it against the target, it appears that they're applying it against the full height of the target, which in Al Kay's case was 1,100 feet. And I'm thinking, but that mountain will be a dot on the horizon that will be so small, you probably wouldn't even see it with the naked eye, let alone a P900. But when you do get the P900 out, you can see it. So I spoke to Adam and he said, you need to look at Taboo Conspiracy's video on this exact topic. And Taboo Conspiracy had done one, and he'd already done all the maths, he'd done all the calculatings for it. So he'd spotted the same issue that I'd spotted, but he'd already done the maths. And his conclusion at the end of his video was, it appears that the curve calculator on his example that he was using represented reality, but it also if we were to use the same numbers but do it on a flat plane, that would also represent the reality. And his conclusion was both of them cannot be the same if we live on a sphere, because only one of them is right, the other one must be wrong. And I was like, this guy's smashed it, he's nailed it. So it dawned on me that he's already done all the maths for it. So the problem became, it's how these guys, the ballers, are applying this refracted hidden value on any target at all. Now, basically, what I've worked out is that once it goes to above like 20, 25 miles, the refracted hidden value will be applied against the absolute height of all the targets. But in real world, when you come to do these observations, because things get smaller over distance, basically, if we live on a flat plane, things get smaller, and that's the end of the discussion.
They appear to get smaller. You got to be clear about that.
Sure. things appear to get smaller. That's quite true. But if we live on a ball, not only do they get smaller, but they tip backwards a little bit. A bulge magically arises between you and the target that's supposed to be half the distance away, but actually is only about 5% according to the curve calculator. But basically, I realized that the hidden value that's down here, we should be putting the mountain in, or the target that we're looking at, subject to perspective, because things get smaller as they get further and further away, because that's what we actually do. But because these guys apply it from the side profile, they put the mountain in at full height down here. But in real world, the mountain's a little dot on the horizon. Now, if we live on a flat plane, things get smaller, and that's basically it. It'll sit on the surface level, and it'll be on the surface level as a little dot, and that's the way we see it. But if we live on a sphere, that little dot then also has to drop into that hidden value. And once you get above 25, like 20, 25 miles, almost all targets that we're looking at are tiny on the horizon. And obviously, if that little tiny thing drops into the hidden value, it's going to be consumed by the curve that is supposed to be there if we live on a sphere. So we had a back and forth for weeks with Nathan, and basically we managed to refine and hone in the argument. And the argument is simple. What they're doing, when we get present evidence for scrutiny and we put in these numbers, they are applying this value here against the absolute height of the target that you're looking at. So if it's a 1,000-foot mountain, they're putting in the full 1,000 foot. But what that does is it maintains the whole height of the thing that you're looking at, so that the hidden value is always there or thereabouts. And what that also ultimately does is makes a curved ball, a curved surface look flat. So they're ignoring perspective completely, applying an absolute value, which makes it look there or thereabouts in almost all cases. And somehow we all got this mathematical construct that makes a curvy ball look flat, and we don't quite know how they've done it. But now we've worked it out, this perspective thing is actually a thing, and these guys are not telling us that we have to apply perspective. So the main argument was, is the curve calculator wrong? And the answer is, yeah, it doesn't tell us that perspective is a thing. But every baller that's ever used the curve calculator, and it's not just this one, it's all of them, if once they apply that hidden value, be it the metabunk one or even just the hidden one that's there, they always apply it against the absolute height of the target that you're looking at. They don't take into account that things get smaller over distance to the observer, or they appear to get smaller over distance to the observer. And ultimately, we're doing ourselves out of the truth, because we haven't realized that there's a sleight of hand here. And the sleight of hand is they turn it into an orthographic representation of the world that we see. And of course, nobody sees it this way. We all see it down the lens of the camera, down the lens of your eye, and we see that things do get smaller. But if we lived on a ball, they would drop behind that curve as well. And that's what they're doing. It's the sleight of hand there. And I'm hoping that you guys can critique this as well. But fundamentally, we see things getting flattened, and we see things that should be dropping behind curve, not dropping behind curve. And somehow they explain it, and it seems to be explained and accepted as true. But somehow we all realise somehow the sleight of hand here. It's like that £3 coin thing with the waiter. Where's that pound gone? Well, we know that curvature's gone missing somewhere, but we can't work out where it's gone. And that's what they're doing. They're making it disappear by applying it against the absolute target height. And we're doing us all out of the curvature that should be there.
Yeah. Like if we lived on a ball, then distant objects would physically fall along the curve. They would also apparently diminish in angular size due to perspective, and they would also vertically drop apparently due to refraction. So you would have actually three things, but we'll just forget about refraction and say that, yes, if we lived on a ball, then perspective would apply and vertical descent due to curvature would apply. However, they completely eliminate or don't even factor in the perspective part of it. And, for the longest time, I couldn't understand why globe earthers agreed with Dr. Rowbotham's 8 inches per mile squared argument, because I kind of figured that they would argue with a flat earther on every point, even if it was valid. But again, it comes back to this, is that Rowbotham didn't consider this either. And even with the 8 inches per mile squared, which does not factor in perspective, we still don't see the evidence for the ball, but it makes it debatable when you add in refraction and invert what refraction actually should do for the globers. But yeah, that's something that I kicked around a bit in some videos a while back, and totally agree. I think that there is no arguing against the fact that we see in perspective, and so vertical curvature calculations should include the object of perspective in it, yet none of them do. So it's a problem.
Yeah, they make the adjustment for standard refraction, right? Which, if they're prepared to make that adjustment, they should make the adjustment for perspective. But what we realized is that when I went to the beach and I got that same footage from Lay on My Belly at kind of like 1 foot above the water, we realized that, hey, if we can see that from 1 foot above the water, what else can we see? Now, as it happens, Ranty lives right near the beach. I think he lives about 4 miles from the beach. So it's not that much out of his way to go to the beach regularly. And that's what Ranty started doing. He started to go back to the beach, find something that's about 20 miles away or so, and then basically focus in on it and then see how low you could go. It's a bit like limbo. Is it what's it called? Is it limbo, where you go, see how low can you go? Well, Ranty's been getting it right the way down to like 1 foot above, less than a foot above the water, the waves, the water coming in, and you can still see the beach like 20 miles away. So Ranty's been on a gold mine chase at the moment. And I mean, I'll give way now because that's kind of my part done. But really, when Ranty shows what he's about to show you now, none of what he's about to show you should be visible on a sphere, because there should be that thing called curvature. But right the way down to the waterline, Ranty's getting the same stuff, the beach, over and over and over again. So they can't argue that it's special conditions that's causing this refraction looming thing from behind the curve of the Earth. he's getting it every single day. So I mean, I'll give way. Ranty can step in and show what he's got to show, and hopefully you'll be wowed by this stuff because it's absolutely glorious.
Okay, cool. Well, while Ranty gets ready to present, so this and this admittedly is my kind of area of weakness. So, but fortunately, I have Jaron and John and Iru to take up for me in this particular area. But Jaron, I think you kind of have similar opinions about the idea that we are not compensating, or we are not factoring in the fact that when we're looking at something, move further and further away from us, its angular size is reducing. And this is one of the points that you brought up when addressing Jesse Kozlowski and how they are, tricking themselves essentially into believing that we're on a ball. So I just figured you might have some comments on that.
Yeah, no, I see it the same way as they're seeing it. In my opinion, I wouldn't say that the curve calculator is wrong, because the curve calculator is not taking into effect the size of the item that you're looking at. It's actually just telling you how much of a item, item X, should be hidden. So I think it's a crafty way of making it so that the curve calculator is correct. However, if you are just applying it as is without the without the note that things get smaller with distance, then you're going to come out with a result that's not going to be correct. It might match observations, but it's not correct in the world that we see. Because my explanation for the curve calculator omission is this, and people can take it or leave it. But if items in the distance appear to get smaller, we know that to the observer, then that must be taken into account. And why I say that is because let's pretend that we lived in an atmosphere where things in the distance got larger. Well, would that need to be taken into account? Well, obviously, yes, because if something is 20 feet tall and it's supposedly hidden by the curve and just right at the tip of it, that's where it's going to be according to the calculator. Well, if things appeared 3 times as big in the distance, let's just say, well, then it would need to be taken into account. Obviously, that 20-foot building appears to be 60 feet and therefore would stick up over that hump, and we would need to take that into account. So if you need to take into account if something's bigger in the distance, then you need to take into account if something is smaller in the distance. And that's what is not being done. I think that Sleeping Warrior described it perfectly when when you're looking at the circle head on or looking at the side view of it, then the curve calculator is correct. But if you're talking about from the observer who's measuring it, then it's not.
Right, because what we're actually seeing on the plane is a combination of perspective and refraction, and that's it. And it does give this illusion of a ball. But if that is indeed what's occurring on the plane optically, apparently, then that is what we should also expect to see if the Earth was a ball. And it would be exacerbated by the curvature. And frankly, the whole thing falls apart, even the 8 inches per mile squared, when you're talking about first-person perspective as opposed to that, sort of side view, third-person perspective. The whole thing really doesn't work, other than in just mathematical scenarios that really don't exist. Because of course, when you are standing in that third-person perspective, if you watch a ship go across the horizon, it doesn't go along any sort of curve at all. And yet that's what we should see, and that is what they're claiming we should see from this sort of curvature calculation. And in fact, it isn't seen. So yeah.
All right.
Total. When you want, I like I have a few my simulation things to share about this topic. So you
okay.
told me.
That'll be cool. We'll do that. I'm going to go ahead and let Ranty show some of the stuff that he's doing. And then, Iru, one other thing that I do want you to kind of go into, we talked about this a little bit last week, but as you can see, this video that I'm playing right now, which I had everybody watch last week, the Red Pill Philosophy, I thought it was a really great demonstration and example, and it it does appear to go right along with exactly what Ranty and Sleeping Warrior are talking about. However, I know that you did have a couple of issues, and one of the things was about the camera level, and so you may want to kind of gear up to address that a little bit as well. But right now, Ranty, if you are ready, I'm going to go ahead and switch over to you, and you can show us what you got.
Yeah, sure. Just one moment. Let me find my start point.
Okay. All right. Well, he gets that ready. I think I had another announcement, but I can't remember where it was. So that's okay. Let's call that a senior moment. We'll just wait for Ranty to get going.
Sorry about this.
No
Well,
worries.
I had it.
Whilst Ranty's looking, what I'll do is I'll echo Jaren's words and say that the curve calcs are not necessarily wrong, but what they've not done is told us that things do get smaller in the distance, and that omission is important. So it's not that it's wrong about what it tells us. It's wrong about what it doesn't tell us, because it does need to tell us that things get smaller over the distance. Otherwise, we'll just apply their maths and it'll come out flat or curved, whichever way they're going to present it.
Hey, Bob, I did drop something in the chat too. If you wanted to show it, something else I showed on that live stream that's funny is a article from the Independent that says the universe is just a big hologram. Astrophysicists claim, and then I read the next line, which is classic. It says, "There's as much evidence for the holographic universe as there is for the traditional explanation," researchers said, which I just thought was hilarious because when's the last time you landed a remote control rover on a hologram? But supposedly we've landed one on Mars. But if there's just as much evidence for the holographic universe as there is the traditional one, that tells you how much evidence we have of the traditional model, huh?
Yeah, they do seem to keep sticking their foot in their mouth, don't they? That's hilarious. Okay, go ahead, Ranty. You are presenting.
Yeah, I am ready to go. Right, okay, so the first time I started looking into perspective and the angular size change at distance was when I was on, I was asked to go on Red's Rhetoric's channel and chat to him sometime last year, so it was perhaps a year ago now.
That must have been fun.
Yeah, it was a baptism of fire, that's for sure. But I held my own, considering I'd only been in the flat earth for a couple of months. So this was some footage that I'd taken of two separate wind turbines at turbine farms, but at different distances. I think this one's near 20 miles and this one on the right was about 11 miles away. So this is still the same focal length, but you can see perspectively they look quite similar. So I ran through and I resized the nearer ones, just squashed the image. And what I got was some workings out, which are here. These are the Reese flats, hub height 80 meters, curve calcs hidden 59 meters. So essentially, where my cursor is now, that's where these hubs should have been missing. And again, with this one, we would have been missing 13.8. But if you've ever been looking at these wind turbines, you can tell that you're seeing absolutely down to the floor with this little knuckle that's on them. So when I compare the two, and I've just put them at the same height, you can see they're pretty much identical. There is no change. They're identical in my opinion. And that was my first delve into that. Whereas essentially there should have been a 50-foot, 45-foot meter discrepancy between the two, and clearly that wasn't evident. So that was my first look into perspective about a year ago, and it was through using these turbines that I was able to do some of my calculations recently. I'll look at this one. So yeah, this is what I'd first displayed on Nathan's channel some time ago. I'd worked out the distances in miles to each of these turbines. I plotted the wind farms out onto Google Earth, and so 11.55 miles was this turbine from my location, and etc. This was the curve calcs for those distances. So I also noticed that this seems to be going through in a very straight line rather than being incrementally further going over the curvature. It didn't appear to me to be doing that. I put a line in. I'm wondering if I've got that one ready. Probably haven't. But yeah, I put a line through the hubs, as you can see, right through the center. There is no curve going on, even though this turbine on the right is further away. It's a further near 2.25 miles away. You should have seen a little bit of a curvature. But what I figured out was that if I carried on this line and I worked out whether it would meet the horizon, at what distance it would meet the horizon, was technically what the curve calcs would have said. So using the hubs as a kind of guide, it matched in perfectly with the curve calcs. So that was the first another look into how they could be hiding perspective into the curve calcs. Here's some more turbines looking down them. So essentially, we're looking almost directly down these turbines. So the one at on the right is about 2 miles further away than the one on the left. But again, you can see that they're not curving; they're just going further away due to perspective. Their angular size change is getting smaller, and they appear to be smaller in the distance. I'm just trying to think what to show you next. I don't know.
Ranty, show us the low-level stuff that you've been getting of Barrow in the last couple of days.
Well, yeah, I will do. Don't worry, I'll get to that. Here's the lampposts. So essentially, this lamppost probably by this van, the distance is about a mile away. This one is right next to me, but it's only a third of the height of this one. Yeah, if you was to take the curve calcs and say, well, 1 mile away, 8 inches, essentially that should just be 8 inches different. But it's not, because it's not taking into account perspective. Does that make sense? Because if you looked at this image, you would say, okay, that's a third of the height. It's lost 60 feet of its height. Where's 60 feet gone? Oh, it's gone over the curvature of the Earth. No, it hasn't, because it's only 8 inches apparently. But clearly, that's just due to perspective. Things in the background do get smaller. Let me show you. Have you seen my boats? Some of the boat stuff that I've been working with as well. So this was an elevation change on this particular boat. I was at Hoy Lake with Anthony, and the altitude here was 11.2 meters. And essentially, I ran down the hill and took these images over a period of about 3 minutes. And as each elevation change, I've put the details in. But can you see where the boat seems to be miraging itself into the horizon?
Yep.
And as I go through all these, you can see that the boat itself is pretty much disappearing, but it's disappearing into this narrow band of air. Now I've got a comparison at the end, which shows that if you took the hard horizon and you put the boat, you went to the top of the boat and you put the stick at the very top of this boat, and you got the hard horizon here. Well, it's the same on all of them. That stick is still sticking out here in the same position as this, and it's not changed at all. So it's showing that it's not going over the curvature of the Earth. It's just being miraged out. The boat is there. It's in there somewhere, but you just can't see it. And this is the thing with trying to figure out what perspective will do to the human eye. And we can't model this in 3ds Max, or you can't mathematically predict this. This is just what happens. Real world experiments show you different weather conditions and blockage, and it's not through curvature of the Earth. It's just atmospheric. That's what I found anyway. Do you want to see some 1 foot observations? I can play this video first, actually. Perfect, right. So on this was the same day that I got my 1 foot observation of Barrow in Furness. Now, can you see the turbines? What's happening to them? I'll let it play.
Yes, it's turning into like the Jesuit sun, the wave.
Maybe your camera was on acid that day.
Well, it was so strange that it really did stick out to me that I had obviously seen the turbine blades being stretched towards the horizon quite a lot, but I'd never seen them bent like this, and I felt like I needed to film it because it was really odd. Well, this is why I think it was so odd, was that I got my 1 foot observation here looking over at Barrow. So everything seems to be being doubled up on itself upwards in this video. You'll have to excuse it because I was doing it free-handed. I didn't have a tripod that would go as low as I was trying to get. Just let it focus in a minute. And when it's focused, hopefully soon, Yeah, so this was the same day, and I'm seeing all of these buildings, but they're being miraged up. But the bottom of the buildings are all clearly visible. Now, I'm going to show you the still shots that I took from this particular observation because it's going to blow you away. I mean, this is literally sand shore to shore over a distance of 18 miles. So let's get off of that and show you these still shots. So yeah, so still shot number one. So this is shore to shore, but what we have is we have a refraction zone that's starting higher up. It's starting here. There's only 2 windows on this building, and the refraction is just happening here. So it's kind of lifting up, but it's only in a very narrow band. So whatever was happening, it appeared to me that I was getting underneath the refraction zone on this day. I know it sounds a really weird concept to talk about, but I truly believe I got underneath this layer of atmosphere that stops us seeing from shore to shore. This is a rock that's on the actual shoreline. There's a medical building in Barrow. There's a seawall that goes around it, which is covered with sand dunes. So this is all just sand dunes. All of these buildings should be gone. You shouldn't be seeing any of these. Let me show you. I might have a comparison for that actually.
Okay, hey, Darren. Darren?
Here we go.
Yes, sir.
You might want to turn slow mode on your channel. We got a bunch of idiots spamming it.
Okay.
Okay, so I went up and I replicated the observation from a further distance, but higher up. So essentially I was looking at this from an elevation of about 30 feet or so. So what I was doing was I was getting a like for like, and I managed to get the rock in the foreground next to this building. Obviously, this is the lower image of a foot, and you can see this is all that I would ever have seen from this distance. That's it. It's just sand there. There's a sand dune that's in the foreground. Sand dunes in the foreground on the 1 foot observation, and it's absolutely floor to floor. Now, I kept this image in. I was going to put it underneath, but I just wanted to show you the sea because look how flat it is. I'm looking for the hump and I can't see any.
That is amazing. And
There's no
what I
hump
find
there.
interesting is the lensing effect about how it's magnified in the top part.
Oh, here.
Yeah. I think
Yeah,
that's amazing because Rob Skiba talked about that with his footage that he was taking as he was approaching Chicago when they were riding the boat over, right? And I looked at yours and it's like that is amazing. And of course the ballers seem to deny, even though he had that expert guy come on, the meteorologist that the meteorologist was talking to. And he's like, yeah, atmospheric lensing and magnification is absolutely a thing, and we could see that very clearly in that last slide you had up.
yeah, and you can see it in this too. This is the clock face being split into 2 clock faces. On the next image, you'll see it almost in 2. So it's actually reflecting up. So this part here of the Barrow in Furness Town Hall is actually a reflection of this part of it here, but it's going up. And the buildings that are underneath are not in that refraction zone, that area that's in where my cursor is now. So all these buildings at the low part aren't being affected, which is brilliant because this is why it shows where the refraction layer was on this day. And that's why I'm saying it's actually a layer. If you look at the next image, you can see there's the refraction zone here, and these buildings aren't being touched, which is why we can see them. I mean, this is shore to shore.
That's interesting. I think if maybe you had different temperature conditions, like on a different day, you might not get that, or might have a different elevation of that. I'm sure it is variable depending on lots of different things, but like temperature or barometric pressure and humidity and that sort of thing.
Here's a lighthouse. It's about 13.3 miles away. You can actually see there's a sand dune in the foreground, and behind it is there's a house that goes along with the focal height of this is 69 feet. So this lighthouse, and its house is there. You've got 3 chimneys, and you can actually make out the 3 chimneys that are just peeping over the sand dune. So, yeah, I mean, it was a great observation getting down to this 1 foot on the refraction layer. You can actually, this is a great image to show you this refraction in action. You can see the split on the roof. It's no longer got the 4 windows. It's now just got the 2 windows. So this is the building, and this is the refraction zone up. But again, shore to shore, you shouldn't see these buildings. But I'm seeing this on a daily basis. This is just the clearest day that I got it.
Yeah, that's really amazing footage.
Let's see. Oh, yeah, I can show you.
And this is all done from 1 foot over 18, 20 miles. There ain't no bulge. There ain't no curve. We're seeing shore to shore. There should be a wall of water between us and the target that wipes out all of that, what you're seeing right now. None of it should be seen. It should be behind the curve, which will be water. And we're not seeing that bulge.
So I went up the coast,
Right, and that's even figuring in or not figuring in rather the idea of refraction and perspective in the curvature calculation. That's going ahead and handing the Globers that things do not apparently diminish in angular size with distance, which is of course not true. But it's giving them the benefit of the doubt a great deal, and yet we still see the entire building, right?
You do, and about a couple of people say, how come we don't see the base of the buildings? Well, this is the answer. This is the sand dune in the foreground, and you can see the house. There's a house here that's set behind the sand dune. There's the sand dune in the way. It's like its own seawall, the location of it. So instead of having a seawall, they've got this sand dune that goes around. It protects them from being swamped. So let's see what else I've got for you. The compression. This will blow you away. Honestly.
Yeah, this is amazing stuff here.
This is going to blow you away. I guarantee it. Watch your faces hit the floor. So this was taken from a distance of 20.4 miles away. And I was holding the camera down at my ankles, basically at a foot. So I took this image 20.4 miles away. The next image I'm going to show you, I got in a direct line behind it, an absolute direct line behind it. So the steps were beneath me, and I got in the same line of sight. So there was no parallax issues. And I took this image from the same spot, basically. Well, this was from 30 feet. And I went back and I measured it with a tape measure. I've got the video of that if you want. I'm not going to play it right now, but I can do. I've got the video of me measuring the actual heights. What I'm going to do is I'm going to open up this in Paint. And I'm going to do some trickery with you. Okay. Well, not really trickery, but I'm going to show you how the trickery has been morphed into the curve calcs. So I'm going to open with paint.net. So now I've got the 2 images up. There's no parallax issues going on. So
whilst he's doing this, what I want you to be considering is how would this be explained on a ball? Because on a plane, it's simple perspective and it's squashing towards the horizon because things are getting smaller. But how would this be explained on a ball? If refraction is bending things up from behind the curve, that would give you the impression that things would be getting stretched rather than compressed. So really, it's like, what's the explanation for this on a ball? Is this proof of a plane that I've not seen before, but is it proof of a plane?
Right, and of course the other thing is we have not one single example anywhere of anything being able to bring up any image up from behind a curve, unless of course you start, and this isn't even behind a curve, but the closest they can come to it is like a superior type mirage, and that turns up as inverted. But even that is not bringing up anything from behind a curve, behind a physical obstruction. There is no example of that. There's no demonstration. There's no lab experiment. There's nothing. It's simply, it doesn't work that way. So the ballers are operating from a false premise in the first place.
No, in fact, all is like when they try to detect the motion of the Earth. The same thing happened with the refraction experiment. They proved that everything is against the theory because the object is going down, not up. So any test that they made showed the opposite conclusion.
Yeah, that's actually right. Every test that has been made has shown exactly the opposite, which is pretty damning. I mean, and what was it? There was that one experiment that Mick West had on his website, right, Iru, where they were trying with what gas was it? Butane, right?
Yes, exactly.
And
And
they're trying to make the claim.
yes, in fact, I have my presentation is a little bit about that, complementing these great presentations of the Sleeping Warrior and the other guy
Renty.
who Ranty.
Right.
So
Yeah.
it's about that. It's amazing, man, and great presentation, really.
Right. Okay. Shall I carry on?
Yeah, go ahead.
Yeah, sure. Okay, right. So all I've done now is I've just cropped out the top image. So from the 30-foot elevation, I've just cropped it out just so that I can overlay it onto the 1-foot observation in a moment. What I need to do next is just go to where are we? Have I got crashed?
Oh, not again. I think it's trying to load thumbnails for all those things, possibly.
Oh, is it?
Oh, maybe.
It
I don't
wasn't
know.
me. Wasn't me, I swear.
Oh, it's okay. Yeah, these computers have been acting a little weird. Between computers acting weird, Skype acting weird, and all these other things, we're just kind of running into a few issues here. Yeah, Randy was having this problem yesterday when he and I were talking about this, and I think ultimately you wound up leaving and rebooting, right?
Yeah, this is. I think it was at the same spot as well that I was showing you this. It's weird how this has happened twice.
Yeah, it is. Well, if you want to exit and reboot, that'll be okay, and we can continue.
Are you
on
sure?
when you come back? Sure.
Okay.
No
I'll
problem.
be back in 5 minutes.
All right. Cool. All right. So, let's see. I guess I can cover one little quick thing here before Ranty comes back. So let me go ahead and kick my screen sharing back on over. Where is it? It's that one. Okay. And screen share left. All right. So hopefully everybody should be seeing my stuff here. Oh, by the way, John, this was really a good video. I put it on the 24-hour feed. I really liked it. Hopefully we'll get a chance to talk about it here in a little bit. But okay, so one thing that I wanted to show last week when UAP was on, he talked about an experiment where they were dropping different elements in a vacuum chamber, and they were not falling at the same rate. And it all had to do with different charge potentials of these. And he just sent me a really short clip of it, which I'm showing right here. But again, so I'm sure that somebody will eventually elaborate on this experiment, because this doesn't really seem to show a whole lot other than, from what we can see from this small demonstration, that objects specifically that have different charge potentials absolutely do fall at different rates in a vacuum. And I thought that was, pretty amazing, because again, we were talking about the whole idea of the electric universe gravity theory. And, I've mentioned before that you have hydrogen and helium, and they have a very minimal electrical structure. And that is why they are not as susceptible to the static dipole alignment effect. Well, apparently these particular elements that he's testing are also falling into that same category. And when you look at these things really closely and how they're coming down, you see that, and I haven't done this yet, but you will see most likely, in my opinion, that the different charge potentials of the objects themselves will indeed determine the actual rate at which they fall. But experiments like this debunk the entire idea that everything falls at exactly the same speed. And, and maybe that would be true in an actual gravitational model, but it is absolutely not true in the static dipole alignment theory that the electric universe and that we have kind of adopted, with our models. So I just wanted to bring that up. So let's see, Ranty, are you back?
I'm
Yes,
back. Yeah, yeah,
you are.
I'm
Okay,
back.
so I'm going to go ahead and kick over to you now, and we'll try it again. But I just wanted to throw
Okay.
that in there with everybody.
All right. Okay. I'm actually going to start on something different actually first. Um, this was I'm calling it the compression zone simply because this is the same boat but from two elevations. This is an elevation of 30 feet, sorry, 40 feet, this bottom one, and this one was from an elevation of 1 foot. Now, I'm saying that we're seeing all of the boat, and the reason I'm saying that is that the orange line that runs underneath the Stena line, you can actually still make out the STE, but you can see this orange line that runs underneath it. Now, again, if you look at the bottom of this boat, it has an orange line underneath it, but it doesn't have a mirroring orange above it. So this orange line underneath the Stena line can only be the bow. That's the only thing it can be. Now, what I did is this particular part of this boat is I've cropped it out from this image here, this top image, and I've lined it up across the two, and you can see there's no real compression going on at all. They look the same height from the orange buoy up to the top of the boat. Orange buoy up to the top of the boat. It looks identical. The only change is on the very bottom of the boat where it gets really compressed. The width is still the same, it's still the same width of boat, same length, everything's identical apart from this lower part. Now, like I say, it feels to me like I'm seeing all of the boat because I can see this orange part running underneath it.
Devon, can you see that if this was ballers, they would get the blink test and they would get the image at the bottom, they would blink it over the image on the top, and they would say, "Where is the rest of the boat?" And Sean Hufford would do that in a blink tomorrow. So it's like this is what they're perceiving will be curvature, and any obstruction is curvature, but actually it's being squashed, and that can only really be for me is perspective.
Yeah. And I got it another day. The next day I went and I got a better image. So this was the two bottom images are the ones we've just been looking at, and this top image was taken again from the same location at a foot. And it's much clearer on this one that you can see the orange running underneath the Stena line, right? So that is a very, very clear indication that we are seeing all of the boat completely, but it's just being compressed at the lower part. Now, it got me thinking, well, is this a one-off? Is it a one-off? And I don't see it being as a one-off. I went and I looked for some more images through my repertoire of stuff that I've collected over this time, and we come up with the sea truck. And this is an image of the sea truck that I got off Google, and I've got it in the same. It's lining up the same way, so I've got it the same width, same length. But look at the change in compression. Look how it's been compressed down. This was an image from a foot again. This top one, it's all been squished, but it's not been stretched. It's been squished.
Right.
So what's the science, Bob? What would this be explained as on a ball if we did live on a ball?
On a ball? Good question. I mean, it's fairly easily explainable in the flat Earth model because this is a result of refraction distortion, and our the bottom part of our angular perception kind of closing up on this, and that's where we're getting this compression effect. So at least that would be my understanding on this. But as far as how it would apply on a ball, I don't really understand. Do you guys have any clue?
No, I don't think so either.
No, yeah, it doesn't work on a ball, that's for sure. It's perspective and maybe a little bit of atmospheric distortion towards the bottom there, but yeah, doesn't work on a ball.
I can't see how it can work on a ball, and I'd invite any baller to explain the science behind why things can appear to be compressed, because it only makes sense if we live on a plane.
So I was sorry, go on.
I was just going to say, there obviously, Tony, there are a lot of atmospheric phenomenon that would work, on a ball or a plane, because it really doesn't have anything to do with the curvature, but more so with, what's going on with the atmosphere itself. And, that combined with our angular size perception and all that stuff. It's only when you put it on a ball that it exacerbates that problem, right? So a lot of stuff, the explanation would be the same, but the problem with the ballers is they're trying to say that all of this phenomenon is produced because it's being physically hidden behind a bulge in the earth or behind curvature, which of course is nonsense, right?
Ronty, if you get a minute, can you
Yeah.
play that one where you have the big boat passing behind the smaller boat in the foreground, but they're both on the horizon?
I will.
That one's really interesting because of the reflection underneath it. Because if there's a bulge between us and the two objects that we're looking at, or there's supposed to be a bulge, how is the mirage or the reflection underneath the boats being explained when both boats are being reflected underneath each other? It's glorious. I mean, when you see it in a second, if he shows it, you'll see it and you'll be like, "Go on and explain them reflections."
Okay, I will do. Yeah, I will. I just want to do this point now because I've just showed you the boats being squished rather than stretched. So this is the top image. This was taken from an elevation of 30 feet, which I physically measured. And this one was taken from an elevation of 1 foot. I can show you on Google Earth. Where are we? Google Earth. So this was my location. So essentially I took it from the bottom of the steps here, and then I got in a direct line of sight behind it on the wall here at 30 feet. So there was no parallax issues with it. So the distance to that was 20.4 miles. So let me get Google up. Let me just, this is where I'm going to work out the mathematics at play. Curvature calcs. And what I decided to do was apply that same logic using the curvature calc. So I'm going to put a distance of 20.4 miles in, and I'm going to put a viewer height firstly in of 1 foot. So my 1 foot observation gives a hidden of 245 feet. And when I put the elevation of 30 feet in, it gives a hidden of 125. So what I decided to do next was do a calculation and work that out as a percentage. So I did 125 divided by 245 equals. So that lower image is 51% the height, the size of the top one. So if I figured out if I divide it by 49%, the top image, that should bring it to the same squishiness as the top one. So when I go back to paint, so now all I have to do is resize this. Don't do the aspect ratio, so I'm just reducing the height of it by 49%. So 568, let me do that on the calculator. 568 divided by 100 times by 49. So if I change that to 278, so if I change that to 278 in height, I've now applied a squishing factor to it, like with the boats. So if I select it now, and then I'm going to compare it with the lower image and place it over it and see what happens. See if you...
Wow, look at that.
So all I've done is I've applied that same logic with the boat. Image, I'll crop to the selection, so hopefully it'll make it larger so you can see it all. So that's what we get. So I reverse engineered the curvature calcs, their percentage of how much should be hidden, and I applied it into a compression of the lower image, and they're essentially a match, like for like. You wouldn't spot any difference.
Yeah, very close. The only difference I see is the sort of crispness of the closer image. Obviously, that's because there's less stuff there in between your eye and the object, right?
Yeah.
But other than that, yeah, they're very similar. Yep.
So it kind of makes me wonder: have they sort of co-opted this, squishing as being part of this equation for curvature? And it maybe if you reverse engineer that to other images that you can take from different elevations and see if you get a comparable result.
Yeah.
But I already have that though, because I did comparisons from different elevations, looking across to these buildings. The top one, essentially, is just like a guide. It was from 17 miles at an elevation of 60 feet, and then the next one down is 18 miles at 1 foot, 18.3 miles at 1 foot, 20.4, 22, 24.5 miles, all at elevations of 2 feet. But you can see that they're being, in my opinion, they're being squished rather than going behind a curve. Well, bearing in mind that none of this should be seen anyway. I mean, you shouldn't see any of these buildings. They're not really there. They're a figment of our imagination. We don't see them. They're holograms. But this is the buildings for sure. This is definitely these buildings from an elevation of 2 feet, 24.5 miles. And it looks to me like, because the white, this is the good thing about them, you see, they're very bright. And whenever I take these images, I've got the sun directly on them. So these are all lit up very nicely. So this is why I'm seeing these, I believe, because it makes them very reflective, so I can see them, even at very long distances at low down. And there's the comparisons. Now, these shouldn't be there, like I say, on the curve calcs, if you believe that.
Yeah, that's amazing. I think I just realized something. I was talking about the magnifying effect. Like you've got this top picture, and then the one that's right below that, and I was looking at that as it was being magnified, but it's really not being magnified. It's being mirrored, isn't it?
The top of it is, yeah.
Yeah.
There's a little band that runs through the whole image. It's only about the width of my actual cursor now, and it just runs through the image, and it reflects the stuff up. So it's like the top of this building, which is actually, it's got a V shape at the very top. There's no V shape on that because it's mirroring the underneath of it. But fortunately, the buildings underneath, like these jaggedy roofs on this building here, they're all seen because they're beneath this refraction zone on this day. It was a very strange feeling to see this. It can't be being loomed and refracted, because this is shore to shore, and then we have a refraction zone going on as well, where it's reflecting the image up.
Yeah.
So they can't have it both ways.
Yeah, right. Yeah, no. I just brought that up because, before I said, "Wow, look at that lensing," and it's not lensing, it's actually mirroring. So I just wanted to kind of correct myself on that. Now that I realized actually what I am looking at. So
No worries. I've got where is it? I don't think I've put it in that. There's a few more things I could show you. The mirroring, because I believe there's like different things going on at play in all of this. We've got mirroring, we've got refraction, and we've got the squashing,
diffraction,
the squashing effect. So I think there's only ever 3 things that go on over water from what I've seen. This is one of them. This is the mirroring, where we've got the stenner starting to be repeated in the water line. The refraction takes over this boat, starts to look like it's got a mouth on it. Perhaps I should play Shark Boat. What do you think?
yeah, Shark Boat would be cool. And there's a request from the chat for you to play your windmill footage again, or you already did once, unless they're talking about a different windmill footage.
I'll have a look. Let's see what they say. There's the boat. It looks like it's a shark with its mouth opening up and closing.
Feed me, Seymour.
That one's good, and so is Piranha Boat.
I've got Piranha Boat as well. Yeah.
Yeah,
Well,
but that's some interesting refractive effects there.
definitely. And I see it all the time. I could probably make a living out of just uploading these kind of things. This was what Anthony wanted me to play. This was the obviously, if you imagine that this is what they would class as looming. So obviously you've got the sky reflected back down and underneath the boat, and it makes it, if this yellow part wasn't being visible, and it would look as if it was just being loomed.
clearly that's not the case, because you see that when the boat behind it goes through the screen.
Yeah, just pay attention to the reflection underneath both boats. How is this explained if there's supposed to be a bulge between us and it? It's crazy. This is probably one of his best videos. Look at that now. Stena line is being reflected underneath the hull of the little boat in the foreground.
Wow.
How could that be if that doesn't work on a sphere?
Nope, it doesn't. Well, neither does.
Nothing works on the sphere, man.
Yeah, neither does.
But they deny it though. They dismiss it.
I know. I mean, sunlight, at a sunset, traveling all the way to your feet doesn't work on a sphere either. Neither does moonlight reflections on a still lake. You see these pictures of a moonlight, in front of the lake, and yet you see the moonlight reflection in the lake. And the only way that could really happen if you were on a ball is if the moon was behind you, right? So, I mean, you're right, nothing works on a ball.
By way of segue, just for a yes/no answer, did you see the hangout that I had with the physics teacher yesterday?
No, I didn't.
He's a real physics teacher trained to master's level, and basically he crashed and burned. But I hope he gets to see this show, because I think he was watching. And shout outs to him. His name's Al, but he's only just come into the community as a physics teacher, and he's curious as to know why is there so many flat earthers around, what's going on. And I think he's underestimated the strength of the evidence against the ball. But I think he's in that denial stage at the minute where he's not accepting anything at the moment. So hopefully we'll get him converted into at least realise that there's a lot of evidence here that does not support the ball. He may never jump ship, but he has to at least acknowledge that there's a lot of stuff here that doesn't support sphere. So I hope he is watching, and if he is, shout-outs to Al.
Yeah, in case he is, or any other sort of professors, I've got a couple of math and physics teachers from different universities that are total 100% closet flat earthers, because it's not really accepted in the educational or scientific communities to be a flat earther, but they're out there. And I would just suggest to them, if they have the credibility and they realize that the Earth is a plane as opposed to a ball, that they come forward and maybe ruin their careers. But I think the truth is worth it, because I just can't see more generations of people down the road being taught the ball Earth lies, as long as I personally or we have something to do with it, right?
Yeah, absolutely. So Tony was the physicist you're talking about. He's not the guy that administered the GCSE physics exam to you, is he?
Yeah, that was part of the deal. If he wanted me to take an exam, and I said in return, I want to debate you on the physics of the sphere Earth. So it was a trade-off. So we both got a little bit out of it. So yeah, it is the same guy.
Yep. And for those of you that did not see that, Tony took that exam cold. Absolutely cold, and he passed it, and that's pretty good, I think, because your degree is in law, right?
I'm a postgrad in law as well. The last time I saw a GCSE physics higher paper was in 1995 when I sat my GCSE physics higher paper. I have not touched physics since. I have not done any revision, prep, study. I have no books on physics. All I've done is flat Earth stuff, and all my training and education was in law. And he challenged me, I took it, but in return I challenged him, and he took it. And just check out the hangout last night on my channel; it was brilliant.
So I'm curious to know what kind of stuff was on that exam.
Oh man, there was stuff on that exam I've never even heard of. Positrons. Does anybody know what a positron is?
I do.
I remember proton, I remember neutron, but positron I didn't know.
Yes, I know what a positron is.
I've never even heard of it. I had to make intelligent guesses based on deduced logic, and some of them I guessed and got right, but a lot of it was based on particles and quantum physics that I don't even, if we ever learnt it, I've forgotten it. But like when he gave me two previous past papers, and they were a lot easier because they had like practical applications of things like an Archimedes screw, for example, and it said like the rate of blah, blah, really practical day-to-day stuff. Explain how the current would work if lever 3 was down, that kind of stuff. And that kind of practical application of like thinking is a lot easier to get marks for than trying to explain what would the decay process be when you've got 2 positrons and 1 neutron. And I'm like, I have absolutely no idea what this is. So I found it really like it was quantum physics that I knew nothing about. I had to try and blag my way through it, but I blagged
So
it. and I got
a
through.
lot of that stuff was like essentially regurgitating what you may or may not have read in a textbook. And I mean, we
Well,
all know that that's a lot of what.
A lot of that stuff was regurgitating stuff that I've never read in a textbook.
Right.
But he did reason it out fairly well. That was really you did really well on that, I have to admit. But a
Nice.
positron, for those who don't know what it is, it's just basically the electrical counterpart to an electron. Most people when they think about atoms, they think of them in terms of electrons, protons, and neutrons. But the proton is not just a positive particle. It has a positive charge to it, and that would be by either that would come about by an overabundance of positron particles that give it that charge. So really, it's just the electron's counterpart is all. So anyway, go ahead, Ranty. Sorry about that. I just wanted to bring that up because I thought that was pretty awesome. The guy thought he was going to smack down a flat earther with a physics exam, and you passed it. I thought that was awesome. And
It's failed.
Yeah. But then when it came to the reverse part of it, the debate with a physicist or a physics teacher, the guy brought virtually nothing with him to the table, and he got flat smacked, to put it bluntly. And I don't think he was expecting strong arguments from things like gyroscopes. He admitted he wasn't really up to speed with them, but there are really strong proof for why we're not spinning and why there's no curve. But he wasn't really ready for it, even though we did have full disclosure prior. He knew the questions I was going to ask.
That's amazing.
Isn't that funny? A physics professor knows all about positrons, but not much about gyros.
Yeah.
Well, yeah,
Mathematical garb, eh?
Yeah, that certainly seemed to be the case with the physics students anyway that were involved in the debate in the UK, which is amazing. You know, it just seems like some of the more really amazing parts of physics are left out of the curriculum. But again,
I'm replaced with mathematical garb, the way Tesla describes it.
that's true. I don't know if you guys saw. God, it was I think an ABC News mainstream report, and I have it somewhere, but I can't remember the reporter's name. But basically, he was talking about is a college education even worth it? And he goes into all these surveys and statistics that were taken on students over a period of several years by 2,000 or 3,000 students. And basically what they found was like 40% learned absolutely nothing. 42% of them retained almost nothing, that completely graduated. They found that high school students in other countries were doing just as well, if not better, than American students. And the whole time, tuition keeps going up. There's more A-letter grades than any other grade issued. So basically, what the final conclusion of all of these surveys and everything is that education costs more, students know less. They're failing miserably, and they're walking out of it with a basically a six-figure debt, which was
But
pretty amazing.
they feel great about themselves.
Yeah. So it's just
Well, I can say that I would never be able to afford to do university, both undergrad and postgrad now, with the fees that we get over here. But I also realized that psychologically and mentally, I was not mature enough at the age that I was doing it to understand the stuff that they were feeding me, because it is indoctrination. You don't realize it at the time. But I mean, I'm bringing up these points with the gyroscope with that physics teacher, and he just accepts it, but then drops it immediately because of the preponderance of evidence, things like NASA space pictures and stuff like that. And I'm like, come on. I mean, we spoke about John Savage's gyroscope test, where he put it on the clock mechanism for the 15 degrees of spin in an hour. And I was saying to him, look, if the Earth was spinning and this demonstrates the 15 degrees in the hour, then what you should see is 30 degrees, because the Earth spin would be in addition to the 15 degrees. And he was like, yeah, but, there might be other reasons. And I was like, not really. This is really good evidence that you should be questioning. And being a physics teacher, you should be able to go into the classroom, set your gyroscope at exactly the right angle for where we are in the apparent sphere, and then demonstrate both the 15 degrees and the Earth and the axial rotation in the same experiment. But we both know in 1 hour it's going to do absolutely nothing. And you're going to just go, well, reasons. And I'm like, come on. This is important, and it's not dropped with him yet. He thinks that there's explanations that he doesn't understand, therefore he can just drop it and dismiss it. And I'm like, no, come on, we're supposed to be spinning. Why is it not doing it?
Yeah.
Well, one thing I've come to terms with a while ago is that you're really never going to convince anyone in a sort of a one-off or maybe even 10 conversations or debates about flat Earth. You're never going to convince someone about flat Earth, and especially I think it's proportional to their amount of so-called education or indoctrination. But what we can do is we can show them evidences and make the arguments, and at some point they may go down that sort of road of scientific inquiry for themselves and come out the other end a flat earther. And that's really the best that we can do, because it really doesn't matter what kind of evidences you have, how good you are at arguing or debating the points. If that person is going to believe that the earth is a ball no matter what, then it's really up to that individual to make the leap and really become objective and follow the scientific process, really.
Yeah, absolutely agree. Okay, Ranty, I think
Yeah,
we
sure.
can go ahead and get back to you.
Perfect.
Sorry about
Yeah.
our little excursions, but that's what we do.
Well, now that you've seen the layout of the land, so you know what this peninsula looks like. There's the building with the 2 windows in. Can you see how flat it's become? This is from an elevator. I mean, you can see how low I am. I'm probably 2 inches here. We have a little seagull in the foreground that's floating on the water. So
Yeah, you faked it. You faked it. That's a CG seagull.
Is it CG seagull? Right. Okay.
Yeah. Don't pull an Awake Souls on us. I find it hilarious that I watch you guys debate, and Awake Souls is in there calling every picture you take CGI.
Yeah.
That guy is such a clown. Oh my God. But anyway, continue on.
Okay, so we got the 2 windows of this building, and we've got the those jaggedy rooftops next to it on the next image. Maybe if I get the other image up so that you can actually see it. So there we go. So this is just one of the mirroring ones, but we've got, so maybe that's probably not the best one to show you actually. Just let me find one that's worth looking at. One for observation will do. 702. Okay, so there we go. So yeah, see these jaggedy buildings? These jaggedy roofs? So they're evidenced. There's the windows of the building. So this is obviously, there's the chimney, and there's the rest of the buildings. So we've got that white part of that big building here. So let me show you back to the other image. Where it's gone, the duck one. So yeah, look at the squash. Look how squashed it is. It's like the camera is trying to take all the information and apply it in some pixel or two. So it knows that there's a building there. It knows there's some white that needs to be displayed in the optics of the lens. So it is showing it, but because it's such a narrow angle, it can only show it in this kind of compression. The 2 windows. I mean, this looks like it's been. It just looks like it's flat, and that isn't an accurate representation of what this looks like. It's just been squashed. So this is, like I say, from an elevation of 2 inches, distance 18.4 miles. Here's the building that I was just talking about, the white building. There's Devonshire Dock Hall, which is here. It's the same. It's just been squashed down. The camera is squashing the image. And eventually there will come a point where it becomes too thin to be recognizable.
Yeah, it's not the camera that's squashing it, though, is it, Randy? It's the atmosphere that's doing it.
Well, I think it's just a narrow field of view. I mean, you're trying to look. I mean, at this angle, when you're looking across at a 90 degree, essentially a 90 degree, you're looking at a percentage of a percent in degrees. This building is only a percentage of a percent of a degree.
Right.
Whereas if you were stood up and you were taking the image, you would have a wider field of view. so the camera doesn't have to compress the image.
Well, yeah, I see what you're saying, but what I'm saying is like, for example, when we, get pictures of, people taking pictures of sunsets, and what happens is when the sun gets low enough, it kind of gives this illusion of it starts melting down into the water, right? Which is actually
Yeah.
nothing more than a reflection. And and I think that, because of the fact that you're taking this from obviously such a close proximity to water level, I can't help but think that, that what's happening here is a product of atmospheric refraction and not necessarily a camera lens, compression. I may be wrong. What do you guys think?
Well,
I think the
I think
same.
it's perspective compression, because anytime an object gets distant from you, then it's going to appear to diminish in angular size. And at some
I
point, that
agree.
angular size becomes really too small for any sort of observational lens or eyeball or anything to differentiate between the horizon itself.
Yeah,
And
I
then
agree
you
with
add
John.
the atmosphere. Yeah.
Yeah, go ahead, Uru.
No, I just said that I believe that you're right. I mean, this is, of course, any time that we analyze this kind of image, we must be considered a multiple factors. It's not just one or two. But finally, in the distance, the atmospheric lensing and the refraction compression is based on the condition of the air and temperatures. Of course, we can add the perspective thing and the camera lenses and other factors, but primarily, in my opinion, it depends of the atmosphere conditions.
Yeah, I agree. So, okay, go ahead.
Okay,
Go
yeah.
ahead, Shane.
So right, that was where am I going now with this? I can show you a video that I did today. Just let me today's observations. I dug a hole, and I put my camera inside of it. Just trying to think which one it would be. It would be that one, I think.
Oh wow.
So actually, this is from 1 inch. This is from 1 inch, I think. Yeah, it is. Because I had it on a little tiny mound of sand. Bear in mind that these shouldn't be seen. You shouldn't see any of these. The distances and the elevation height say that the curvature of the Earth, you shouldn't see that. So
Where's that bulge?
sorry, where's what? The bulge? Yeah, where's the bulge?
Where's that bulge?
Yeah.
There's a little bit of sand that I had it on.
Yep. No bulge. And it kind of makes you wonder. It's like, how many examples do we have to give of us seeing impossibly further than we should? And how many times are we going to hear the excuse that it's refraction, and it's a phenomenon of the atmosphere bringing an object up from behind the curvature, which again, like I said earlier, there is no experimental proof of that anywhere. And so why do we, why do we even allow it? And what is it about the ball earthers that they can't simply see that point? I mean, we can demonstrate it on a flat plane. We can demonstrate clearly that nothing will bring an object up from behind a blockage or a curvature. So it's just, it gets frustrating,
Otherwise, we wouldn't have shadows, right?
Yeah. Yeah. I mean, there's just so many things that we have all the proof on our side. And, then they say, well, you guys just deny everything. It's like, well, yeah, but you guys are denying all of the proof, the empirical proof, everything that we come up with, and you can provide no counter proof, other than if you want to be soundly and dishonestly take pictures of refraction, going down and freeze framing it and saying, oh, there's curvature, right? So I just, for anybody that's out there that's new to this or is an unbiased observer, you have to ask yourself, why does this keep going on? Why do they keep denying these impossible distances that we can see, whether it's 1 inch above the water or 500 feet or whatever? When we are taking pictures of things that are hundreds of kilometers away, that just simply cannot be. Not every single incidence of it is some special case of refraction. It just doesn't work that way.
There is a logical explanation for it, though. If you think about it as if you're a fringe baller and you realize that there's a lot of evidence that goes against you, are you actually going to turn your back on them, knowing that there is active trolls out there, and they know what trolls do, right? They know how the trolling works. Would you want to turn your back on the Ball Earth side if you knew that you were then going to open yourself open to be the biggest target for the trolls ever because you've turned your back on them? Because let's be honest, it takes a really strong character to do that. And if you're on the fringe anyway, you're following the flock. You're not leading the flock, you're following it. So are you going to turn your back on the rest of the flock and become the biggest public enemy number one from the Ballers' point of view? I think not.
I think this is one of the... Sorry, can I just finish this point on this video?
Sure. Go ahead, Shane.
Yeah, it's simply that this one, I dug a trench and I stuck my camera in it so that the actual lens was level with the water, right? But if you notice, I couldn't get a levelness. I had to keep tilting my camera up, which is why the focal point of the buildings is at a lower elevation instead of being centered in the middle of the screen, because I had to tilt my camera up to get the image. This is actually inside a trench, so we're not looking down over a curve. I had to look up to get this shot, as evidenced with the fact that I couldn't physically if I put my camera down, I wouldn't have lowered my camera down. I wouldn't have seen the buildings.
Are you sure that those seagulls aren't behind the curve?
And the other thing to point out is that. Go on.
Sorry, I was just going to show that there's the water coming into the actual trench that I dug. My camera was inside that, so there's no denying that I was actually at sea level 0 looking across, and I had to tilt my camera up to get the image. I wasn't looking down.
The thing to be aware of is when you put the curve calcs into this on the MetaFlunk curve calculator thing, this is about 18 to 20 miles away. The horizon, when you're at this level, is less than 1 mile away. So wherever you want to denote the horizon is on this image, so it's like, I mean, the horizon really is where the sky meets the land. So, all right, forget about the mountain in the background. You're seeing 20 miles. But according to the curve calcs, the requirement of living on a sphere is that curve at the horizon at that distance, but also that elevation requires it's less than 1 mile away. Yet you're seeing the other beach that's 20 miles away, and that in itself is a globe killer. But they just turn a blind eye to it and say, yeah, but everything else works, so we'll let that one go. And I'm like, what are you talking about? You can't do that.
Yeah, can't let that go. So okay, Shane. Well, I don't know how much you have left, but I know Iru is chomping at the bit to show his presentation. So if you have anything else,
I've got loads of stuff, but we can save it for a different time if you like, another show perhaps.
Okay.
I was just going to mention that that the people that argue never ending for the globe for the last few years and do everything from enter our hangouts uninvited and broadcast porn to show SpaceX rocket launches as proof of NASA's credibility and infinite space. I just think that they're being disingenuous. They're not actually globe Earth believers, but my personal opinion is that they are somehow incented or given an incentive to push the globe Earth narrative, to continue arguing these points about refraction and curvature, just to give the appearance to any sort of uninterested passerby that there is a hot debate going on and that the globers have a credible position when in fact they really don't. And really anyone that objectively and skeptically goes into this honestly comes out the other end a flat earther, or they're either kidding themselves or they're just bold-faced lying. So I really think that's the answer to why we have to continue showing these sorts of evidences, is because frankly the globe earthers continue to argue the points.
Yep, well said. Okay.
Yep.
Cool. Well, yeah, Ranty, I mean, you have some great stuff, and I know you have a whole lot more. And, maybe if Ira has something you can interject with it. But, yeah, I mean, this is really, really good stuff, guys.
Yeah, I've only scratched the surface.
Okay. Well, we'll do some more. I'm going to go ahead and let Iro take the screen for a bit. And, like I said, in the way we do things in Globebusters, it's round table constantly. if you have a comment on anything that Ira is doing or anybody else, just feel free to jump right in and talk about it.
Yeah, please. In fact, because it's related with this topic, in fact, I'm going to show you, a couple of minutes. I think this presentation covered every thing that I'm going to show. I'm going to show the same thing, but with the different methods, and putting also, because what is amazing about this is everything is real images, and that is awesome because it's based on real action. And I want to try just to show a few things based also in simulations. So please comment.
All right, excellent. Okay, Ursa, go ahead and share your screen, and hopefully we've got this issue fixed.
I hope that. Let me just share. I think it's this one. So
Yep.
are you seeing my screen? Okay. I'm just okay. Perfect. We are good to go. I try to I shared these kind of things before, but I believe this is a good time to share again because it's related with this presentation. So we can put together more information about the perspective and refraction topic. And what I'm trying to, I'm going to start because anything that we saw in this presentation, first of all, I want to say an excellent debate that Sleeping Warrior and Nathan Oakland have with Mike West. That was amazing because he must be admit that this calculator is not considered a real, geometrically situation with the planet Earth, supposedly if it was in a sphere. This assumption that they took based on refraction, trying to transfer into a geometrical situation is totally crap. I mean, it's an arbitrary thing. There is not a real base with real evidence.
That's right. R is an assumed value, and that is it. It's assumed. There's no proof of it.
Exactly. And in fact, that kind of assumption, maybe I get wrong, but it's come from this guy, because when we're talking about looming and similar refraction phenomena, it's really independent phenomena of the Fata Morgana thing, because the looming is not produce mirages. It's just where you see that it's occluded by refraction phenomena, but atmospheric phenomena, but it's not produce any mirage. So the thing that all this calculation assume this supposedly expansion of the radius of the Earth is coming from this scientist, this physicist of the 19th century called, I believe is let me just William Jackson Humphreys. This guy was who come with the if you see something that supposedly you cannot see because we live in a sphere, well, you can do this, enlarge the geometrical planet Earth. And I just pointed out because I know there are some guys out there that like to make a deeper research. The larger size of the sphere, the planet where an observer is located, the less curved the horizon is. No, that is more or less what they trying to do with this kind of enlargement of the Earth. So let me continue. So when you go in the Mike West calculator, when you go to the research that he make, of course, they are referring to a paper in our modern time based on NASA, and that is talking about and trying to cover in the supposedly refraction problem in the horizon gradient. And that is why everything that we must be see in a plane that we live, because they assume that the surface is flat to make all these calculations. It's like when you saw all the CIA paper that assume everything that the Earth is immovable and is a flat plane to build helicopter planes and do a lot of other research. They assume all the time that the Earth is flat, and to explain these reflection situations, they assume that. In fact, in papers of the South American institutions, of course, they assume the same thing. The surface is flat, the conditions are normal, the temperature, whatever, but all the time they make their calculations assuming that the Earth is a flat surface.
Yeah,
So that is,
what's funny
tell me.
about that, Eru, is it's actually that assumption, quote unquote, is actually pretty good because it's not really an assumption.
Yeah,
It's a reality. But
It's a
where the
reality.
real assumption comes from, and like I said, like you pointed out, Nathan and Ranty and Anthony and Arwen basically got Mick West to admit straight up that it was an assumed value. So that's what's really going on here. It's the old switcheroo, right? It's always about, oh, well, it's an assumption that the Earth is flat. It's no assumption. It's a fact. It's a demonstrable fact. And the assumption of R is not a demonstrable fact. And in fact, they have completely knocked it out of the park as being nothing more than an assumption because there's no proof whatsoever to back it up. And even the Eratosthenes experiments, like we talked about a few weeks ago, Neil Dumbass Tyson actually admitted that it would work the exact same way on a flat Earth with a close and local sun. So you just got to love the way they reverse their quote unquote assumptions, right? So go ahead.
Yeah,
Sorry.
yeah. No, it's okay, man. It's okay. Exactly. So, visually explain this gradient when all these distortions has produced is basically is talking about this. Everything that we have distorted image is produced in that gradient area. So that is why for astronomical observations they say, okay, don't take into consideration this. Point the telescope 20 degrees above the horizon, because if not, you're gonna see maybe that the Earth is flat, but with a little distortion. So this is what is happening. Anytime you want to see objects in this gradient, you're going to see depends of the conditions in the atmosphere. Maybe you are going to see. So if you see that day, that is because the Earth is growing and the radius of the Earth is not anymore the official radius of the Earth. Now it's bigger. And if you don't see the object, is because it's behind the curve. So that is, technically speaking, in the a very basic explanation, that is what's going on, and it's not depending on the altitude of the observer. That is why we can see with the camera on the floor, we can see pointing on the sea, we can see mountains or skyline, or we can see even in astronomical observation where the starlight, the speed of the starlight, for example, is accelerating and going down. It's not going up based on that gradient. And we are like 3,000 meters above the sea level in this video, which is in the Mike West discussion forum. And also we can see on the sunset, and this is also 3,000 meters above the sea level. It's not seen on the beach. So we can see that we have this gradient where the object disappears this is a cloud, of course, based on the conditions of the air. We can see here the green flashlight. That is the green flash that in astronomical studies they know what it is. We can see on the sea level the distortion and the mirroring image based on that gradient. And let me go a little forward here because I contrast the image there. So for me, this is one of the best example in real time with the time-lapse video, because you can clearly see here what is going on, which is there is no the Earth growing. It's just that the temperature conditions are changed. So that is why we lose part of the image, and then we won again that part. In fact, in some moment, you can clearly see when it's produced a mirage or Fata Morgana, because you can see the image in mirror mode. So here you can see how it's mirroring, but it's always in that gradient. I mean, the top of the trees on the mountain, that kind of thing is, you know, the majority of the time is stable. It's not a distort image. So this is keep me going. Let me going forward. You can clearly see in this. This is from a movie, the Thomas Crown movie film. And here you can see a camera elevated, you know, just a few meters, how you start losing the skyline in the background. And that is not based, first of all, you can see the real horizon line. From bottom is just a mirror image. And here you can clearly see in the middle how the buildings are disappearing. And that is based on all these conditions. It's nothing there is nothing to do with the curvature of the Earth or nothing like that. It's just the angular resolution, is the perspective, is the refraction, but it's not a geometrical curve. You can clearly see that. In fact, these kind of situations I simulate in this. Let me just open this. This is a very poor simulation, but we can understand it. I have here, what I have here is just a plane, a very big plane. This is like a 100 kilometer square plane. And I have this landscape, which is a mountain. It's just simply, let me just lock the camera view and let me hide the atmosphere refraction. So this is the mountain here. You can see it. I can elevate from the ground. And this is a physical camera. This is this red tag is a physical camera based on the render engine that I'm using. So because I am doing a huge, but really huge focal distance, because I focusing very long, we can start see here a little distortion that these floating mountains everyone is aware to this floating mountain issue that the spherical Earth they can explain. And in fact, if I start making, for example, a zoom to those to some of these areas, and let me, you know, this mountain is atop. If I put it really in the line of the ground, this line is the ground. Yeah, this arrow here, this red arrow is the line base, and this is the mountain. So if I put it in the same altitude, let me just put it at the same height. You can clearly see, I don't know if you are able to see, but let me increase a little bit the screen here. You can clearly see that the factor that the mountain start to disappear from the ground. I don't know if you are seeing that.
Yes.
In the screen. And that is based on this refraction and perspective and long distance situation. In fact, if I, for example, if I put it more, I sink on the ground, the mountain, just for losing, I want to lose this tiny part here. I'm going to do it on purpose. So I'm start going down like that, for example. And I make a zoom with the camera. Let me just make a really huge zoom. You are not able to do this kind of zoom in real life, but that is why we use this kind of software. And let me just move the mountain to the right. You can clearly see what is going on, and this is based on reality. I mean, if I climb up the mountain, you can see how the mountain starts to form. But in this line here, this line is where the real horizon is. In this line is the real horizon. But because the mountain and a lot of time the quality of the image is mixing with the air conditions, you are not have the angular resolution correctly to see what is going on. So for you is the complete image, but isn't the complete image. It start mirroring. So here in computer you can see how the same effect is produced at that line where this phenomena is happened. And this is why we see floating mountains in the real life. It's based on this kind of concept. I want to remember that these softwares are use the Snell law. These softwares use real, physically and mathematical equations to simulate the real life. I'm not programming this, okay?
Eru, do you remember when I showed the composite picture that Ranty stitched together at the beginning, and I was showing floaty land on it?
Exactly. That is why I tried.
Yeah. Now, what I notice is what you're showing in that window there on the extremities where the gap is in the middle. We see the same thing on the composite that we see on Soundly stuff, where Soundly showing it on the Z-axis, which is going out towards the horizon, but I'm seeing it on the X-axis going right to left. So what you're showing on screen, I can show real-world applications of that, and it's the same effect. But what's causing it, I don't know. But you're demonstrating it, and we can see real-world explanations of it. It's brilliant.
I can. Would that be all right to intersect and just show you a very quick video for just 1 minute to show this exact thing?
Yeah, please.
Yeah.
I'm stop sharing.
All right, so go ahead and share, Ranty.
Okay. I've started to share. Let me know when you're seeing it.
We got it.
Okay, so I'm just going to play. And here we have the same buildings looking over at Barrow. And
exactly.
Look at this.
Yep.
Fake waves. It's like fake waves. They're not the real. They're not the real waves. They're not the top of the waves. And this is a floaty building. Well, obviously it's not floating. You've seen that it's actually connected to the floor.
But let's remind ourselves what they tell us the horizon is. It's 1.2 miles away. So how is the reflection of the buildings in 20 miles away appearing on the horizon that's 1.2 miles away? It makes no logical sense.
Totally. And that is the real, and that is why these computer software are based on real life. And show the same thing. And this is in my computer, we are on the flat plane. If I do on the spherical situation, it's not behave in the same way.
Yeah, and they ignore that though, right?
Yeah, in fact, the computer software use the RQT algorithm that is assume that the complete world inside the 3D software is a flat plane.
Yeah. Good assumptions.
Good assumption, exactly.
Yeah. All video games are that way as well. Even though I did see somebody pop a comment into one of the chats, and he claimed that he had worked for a video game production company and that they actually used the ball model. And of course, I find that ridiculous, and he probably was just pulling our leg. But it's pretty well known that all modeling for video games is done on an unassumed flat plane.
Yeah, and Isa Mahalski states that in nautical navigation, they consider 300 square miles as flat.
Yeah. Which is absurd, because if you were to do the calculations of a curvature over 300 miles, it would be ridiculous.
Yeah.
Exactly. No, in fact, something that maybe we must be take into account. Can I reshare my screen or
sure?
I wait?
Sure.
Yeah. No, go ahead, Eru.
Okay. I mean, of course, in our days, the majority of the games are based on Star Wars style. I mean, everything is fighting spacecraft. So, of course, they're going to use a spherical thing. But when they create games of simulation games, not arcade games or, any kind of fantasy world, they assume that the Earth is, they put the flat Earth mode on, based on the Mercator projection. I mean, One thing is a fantasy game, and other thing is simulations games. That is something that I want to take into
Yeah.
account.
There's a distinct difference between the two. Fantasy
Yes,
can be
exactly.
anything. You could be inside of a star or any
Whatever you want.
abstract idea, but a simulation is based on reality.
Yeah, exactly. So this is just a 4-screen composited image, a video about this, that home-based video. This is one from Jeran. This is, I can remember this showing like the sun on the horizon. This is from Rob Skiba, and this is the one of the best videos at the sea level, at the floor level, I mean. But we can clearly see that, anytime that we need to lead with these atmospheric situations, we're going to have this phenomena that the image is going to be stretched, squared, squash, and compress and things like that. Now the situation here is that what you're talking about earlier, Bob, that is nobody show a real lab experiment with the object, which is supposedly like the Canigou situation, 400 meters completely high, beyond the curvature of the Earth, rising up. So there is not any lab experiment where the object is not, based on the is based to be, hiding completely and rise up with any kind of distortion.
Right.
This is an old, what you see here in this upper right corner on the screen is a lab experiment to demonstrate how the atmospheric mirages are produced in the real life. And this is the setup. I mean, the paper with the word Fata Morgana that you cannot see in this image, but it's great in that. The difference density on the water, and the camera, which is out of the screen, is all these three situations are lined up. I mean, this paper is not beyond any kind of hiding curve or hiding object and rise up. So here we can see what is produced in this different gradient of the water. And this is the, regular image. This will be the Fata Morgana inverted image, and this is going to be the superior mirage. So when you see the Canigou, for example, if Globehead want to assume that that is a superior mirage, it's impossible, because the superior mirage always are detached from the horizon line. Never produce a superior mirage at the horizon line. I don't know if you understand what I'm saying. This is in real life, this is a superior mirage, and it's totally detached from the horizon line. You cannot have a superior mirage on the horizon line. I mean,
right. Yeah.
That is the first thing that is impossible. It's a superior mirage. That is why it's called superior, because in the physics world, they assume that the horizon line is in the middle. So when you call something superior, it's because it's above the horizon line, and when you call inferior mirage, is because it's up, in the bottom part. So anytime you want to recreate in the lab this kind of experiment, and you want to recreate a superior mirage, you're never going to have this image on the same altitude of the real image.
Right.
It's impossible. Or I mean, yeah.
Are you familiar? We all know about like the Fata Morgana mirage, right? Are you familiar with the Fata Brumosa mirage?
No.
The Fata Brumosa mirage is where the sea level is reflecting above itself. So you have an apparent horizon which is actually higher than where it should be, because the water is being miraged above itself. So this is like an explanation for why some buildings would be cut off halfway up the building, and they all say, "Oh, it's curvature." Well, actually, there is an explanation for it in terms of mirages. It's called Fata Brumosa, and it's where the water reflects on top of itself from below. And you can't prove that it's not a Fata Brumosa, but they call it curve.
I see as much of that all the time as the same as I would do with mirroring. I say it in quite a lot of my videos that I see the fake waves. I call them the fake waves because it's just an apparent wave height, and it isn't. You can actually see through it. And when the boats go through the waves, you can actually tell that they aren't real waves. It's just an apparent wave.
Yeah.
Yeah.
And for example, when you see things like this of the Canigou effects, what supposedly this is the explanation that they give us, that the sun is really close to the earth. I mean, the sun is here, is down, but everything is matched perfectly to the horizon level. Everything is rising up without any distortion, without any kind of I mean, it's really a fantasy history, this kind of concept. But here you can clearly see how in that distortion gradient, the sun starts to pulling down. It's like first of all, something that I call my attention is if you see the original video, the sun is coming from the top, of course, from the top left part to the bottom right. And when is the transition of this situation that the sun being here to being down here? Because anytime you start seeing, there is no any kind, distinguish situation or time of the video when you say, okay, no, in fact, now it's up there, but now it's down there. I mean, there is no transition of this situation. Because for this kind of explanation, maybe the sun right now must be down behind the mountain and behind the curvature of the earth. Because I don't understand where is the period of time that now is on the top of the horizon or now is on the bottom of the horizon. In which part of the video is that transition? What you clearly see is that 20 degrees above the horizon, the sun starts to melting down, and that corroborate that for me at least is something that you can clearly see this paper of NASA that they say, okay, trying to look at observations of 20 degrees above the horizon line, because 20 degrees below, you're going to have all this distortion where the light is propagated down. So that is why we never saw that kind of experiment on the lab. And then when you start looking into looming and towering mirages, they clearly confirm this situation, because these three images you can see here, these three images are the same focal length of the camera, the same distance from the camera, and we can clearly see that we have floating Islander. We can clearly see that where the object is touching, of course, the horizon line, and we can see a superior mirage. And that, if you start looking, the only thing that is changed is the atmospheric condition and the ray of the light, because anyone's know that the red light is start to decrease the speed of the light. Is a lower frequency. So if you have in the sunset, for example, that is the majority of the time when this phenomena you can clearly see, is because you have more you have less speed in the light. So that is I don't know if I explained it correctly. Sorry for my English explanation, but what I'm talking about is that this is in Spanish, but it says like the red light in the air diminish the speed of light, and the violet light in the air has higher frequency, so the light propagate more quickly. So when you are looking at the sunsets, let me just going forward, you are seeing different light frequencies, and that is why you start losing part of the image, or you're going to see every time that you're trying to make experiment based on this observation, you're going to see that the object is going down, it's never rising up. It's at the horizon line, I mean on the horizon level. So when you start to put in all these kinds of things together, in fact this is a really nice experiment when they project a laser. It's like the Michelson-Morley experiment, but to prove that the light in warm environments are going down. So what is happening here, they have the interference pattern effects, and they took like this hot air device and start to heating the surrounding atmosphere in this particular area, and the light start to bending down. So I mean, you can clearly see, anytime you go to the lab, every experiment you do on the lab is claimed for flat Earth situations, and
Yes.
not for globe Earth situations. That is what I'm trying to say. And the last thing is something that we talked the last show with Rob Skiba about. I make the same simulation as the floating mountains, but with the Skyline City. I put the camera just 1.8 meter, 1.8 meter above this line. This orange box represents the floor, and this green line is the camera. I just put it 1.8 meter above that, and I recreate these atmospheric conditions. And just let me go forward, because what I'm doing here is compare. This black box is the atmosphere conditions simulated in the computer. So here what is happened, it's I'm moving the atmosphere gradient. Of course, I mean that I'm not moving the camera, I just moving the atmosphere gradient, and the object start to cut it off. And like it's happening in homemade experiments. And there are things, I mean, everything you can replicate in lab, you can replicate computer, you can make match the observations with the real life. So there is a few there is a lot of experiment that corroborate our observation. And the last, let me just show the last thing I supposedly have here, but I can't see it. Let me, I think it's, I don't know if it's in here. No, in here.
Somewhere.
No, I think I have here. I mean, I'm saying this, I do the same thing. I recreate, I took this from Google Earth, and I recreate the observation based on Marsella to the Canigou, which has like 280 kilometers away at the height of 600 meters. And this is world record photography. This is an infrared photography. That is why you can see the moon, you can see the Canigou. Of course, it's not the complete Canigou, because we know that we have these atmospheric distortions, the perspective issues, and all that kind of thing. In fact, you can clearly see here the fog line, that because it's in the night, this picture. But we are talking about 270 kilometers at the height of 643 meters. And when I start to recreate this in computer, let me go forward. Let me just, I'm going to do very quickly. So this kind of concentrical circles represent the different layer of atmosphere. Of course, this is a simulation. This is not, scientific exactly what is going on. So I simulate a map to plug into this atmosphere that is, like that distortion in the air. And I apply that into the index of refraction of this material, which simulate the atmosphere. So what I'm doing here is just a quickly demonstration based on the difference or difference index of refraction that the science assume that is the way it is, which is the air and the water. So I just increase a little bit the air index of refraction. I'm never going to achieve the water index of refraction, because that is super huge. And what he's going to see here is in the right side of the screen is just the geometrical view without any kind of atmospheric calculation. And in the left part of the screen, you're going to see the effects with the atmospheric refraction. So what is going on is that at the time that the index of refraction starts to going up, the mountain is going to be start going down, because that is the way that the refraction index behave. So that is what going on with any kind of real life observation, and that is what is going on with the Canigou, and that is why we have a lot of picture and a lot of video with the Canigou cut in the middle, or not in the middle, depends of the observer height and the air condition that at that day, how much you're going to lose in the Canigou effect. So you can here what is happening is just that I don't change the camera height or the mountain. I just change the index of refraction, and you can see how everything, of course, is going down and up. That is just a simple simulation, and repeat, this is not based on super scientific accurate data, because I don't have the date of the day of the observer. But that is my conclusion, is that you can recreate and represent all these real life phenomena in everything, in lab, in computer, whatever is going to point to flat Earth model and not in globe Earth model.
Yep, beautiful, great presentation, Hiro. Excellent.
Thank you.
Okay.
So I've stopped sharing.
Okay, so I do have one question, and I know Tony, you addressed this too, and Jaron, I talked to you about it, but when I was watching one of the Hangouts, from somewhere, I can't even remember who it was. I saw Sean Hufford in there. Oh, I think it was on Nathan's. I saw Sean Hufford in there saying that the Canigou observation was actually at 7,000 feet. And Jaron, I think you had shown a lens height of, what was it, 600 feet? Is that right? Or do I have these all wrong?
Well, hang on. Just before Jevon answers, let me just give a disclaimer. Sean Hufford is the most unreliable reciter of evidence or fact in the whole history of ball Earth and flat Earth discussions.
That
he
may be
can't
true.
cite anybody accurate. He can't. I said to Jaron, if he told me your name was Jaron, I don't know whether I'd believe him or not. And Jaron said I'd have to start questioning his own mum. And that's how bad that guy is. So let's take anything that Sean Hufford says with the smallest pinch of salt ever, and probably consider that it's not actually accurate.
Yeah. So the observation is, the one that I showed, that video, is supposedly from that church, which is 1,000 feet high. But I thought it was funny that Sean said it was from I thought you said 9,000 feet, or what'd you say?
I thought he said 7,000 feet.
7,000.
It was ridiculous.
Well, if you take your mouse and start moving it around Google Earth and try and find the closest mountain that would be 7,000 feet, that puts it back at 250 miles. And then if you do that on the curve calculator, there's even more hidden. So if Sean's statement is true, then there's even more that's supposed to be hidden, and he's not helping himself out much.
Right.
Well, we did a hangout yesterday, and he was going over my 1-inch observation that I uploaded yesterday, and he was calling me a liar, and that it's I'm always a liar, because obviously the focal point of the camera is 1.5 inches, so I couldn't have done a 1-inch observation.
Oh, great.
So he was arguing over 0.5 inch, and for that 0.5 inch, he labelled me as a liar, a fraud, this, that, and the other, and I'm like, are you kidding me?
Let me just put this into context with Sean, right? When we made assertions on Nathan's show and we got it wrong, once we realised that it was wrong, we retracted it immediately and basically conceded. But do you ever see any of these guys calling Sean out for things that he gets factually wrong when he's citing things that such and such a body has said? No. Why is it that this guy's even considered to be like anything other than an idiot? It's mad.
Yeah, that's for sure. And then Tony, you had also another comment when we were Skyping back and forth on that, that you had a different elevation that you had come up with.
Well, I think I was citing from Jeran. Jeran's. I think when I spoke with Jeran about it, I think we were going on 1,000 feet, and I said, was it 1,000 meters or was it 1,000 feet?
Oh, that's
And
right.
you
Yeah, the
gave me-
1,000 meters thing, right?
I mean,
is it meters?
I only. No, I think it was feet, but I'm not
I think
sure,
it's
and
feet.
I didn't know.
Bob,
to be
isn't
honest,
the longitude latitude on that webpage there? If you scroll
I-
up a little bit.
I believe it is. Yes, right there.
Yeah, let me punch that in just so I can see.
yeah, I think what it was, I think Sean was arguing that you'd put feet instead of meters, and I didn't know when I asked you, and Bob got back to me with an answer. And as far as I'm concerned, I mean, anything that Sean says, you have to pinch of salt, right? So I was hoping that Jeran would have answered because he would have been able to cite where he got that info from. But I think from my own memory of that really quick conversation, I think that he was saying that it was 1,000 meters. So let's just address that. If it is 1,000 meters, then maybe so be it. But if it's 1,000 feet, then it just depends on where you got the info from.
Yeah. So what 1,000 meters is what, about 3,300 feet?
Okay, so what do you see,
Somewhat.
Bob, as the I can't look back. What's the longitude latitude again?
The latitude is 43.284323,
Okay.
and the longitude is 5.370511.
Yeah, it looks
You're
like
gonna
it's 1,000 feet.
Right, you're gonna have to show this though, Jeran, because he's not
Oh.
going to believe it if you say it.
Yeah.
Sorry.
Here, I'll go ahead and share it, and I'll present you.
Yep. And what's the longitude latitude again?
Latitude 43.284323. Longitude is 5.370511.
Oops, say that again. It's 5.370.
370511.
Okay, so let me share my screen.
Okay. Yeah, I saw him in the chat going off about that. It's like, get real, dude. All right.
What's he saying now?
You are presenting. No, not now. I saw it in Nathan's chat. But you're
so
right.
this-
He screws up everything.
So this right here says 43.284, 5.37051. And according to this, the elevation is 500 feet, according to this.
Yeah, but what they'll do is they'll add 30 meters to it, plus or minus, right? They'll never minus it off. They'll always plus it on because
Yeah,
Google
you've got
Earth's
this-
always out.
You've got the latitude wrong, Jern. It's 43.284323. Oh, that is what you have. I'm sorry. My bad. God, I was looking at the wrong number.
So this is right?
That 284323 is right, and 370511 is right. Okay, so it's
Okay.
correct.
So this church here, which is something I've mentioned many times before, and I think in all my videos when I show this observation, I always say, let's give it 1,000 feet, because I'm always erring on the side of the globe, not erring on the side of the flat Earth, because I think according to this, I'm not seeing anything above, six something I saw over here somewhere, 600. So, I aired up, and this is where they all go, and they stand in this little parking lot here, and they observe, because if you flip around here, then they observe from this location across here, and that's where they see, so over this way. Yeah, and Kanagawa is over here. And so that's the position that usually people view it from. Now, he said it was 7,000 feet, right? Is that what he said?
Yes.
So if you
No,
just,
I think he's. I remember it being 1,000 meters, but I may be wrong. I mean, I don't really listen too much to what he says anymore.
somebody sent me a screenshot of it, and I thought that it said 7,000 or
I-
9,000 feet.
I thought it was 7,000 feet, but either way, 3,000, 7,000 feet. I mean, he's way off. And the
Right.
bottom line is that should have been hidden behind thousands of feet of curvature.
Yeah. So
And-
here's me trying to find anything close to what he's talking about, and you've got to get way back. This is still 2,000, 1,000, 1,000, 2,000, 2,000. I mean, you've got to get way back here, in which case now you're 250 miles away, and then you're even going to have more curve. So the fact
Do you know
remains
what-
that is one of the biggest globe killers, because they just know that to argue anything other than that we're lying about the distance or where it was taken from, that they have to believe in floating mountain ranges.
Yeah.
And so they don't want to do that.
Guys, did you see Nick from Phuket Words video on how to deal with the reporting of these accounts that imitate yourself, so it looks like it's you saying whatever, and you end up
Yeah.
getting banned from everywhere? and
Yeah, I
stuff?
did see that.
Well, he was showing how to report that process, how to go through that process. Now, obviously, we're all aware that there's imitation accounts out there, and most people realize that it's not going to be the real person that's being offensive because we don't do that. But for some reason, Sean did a hate video about me because he claims that I was claiming that I didn't know sock accounts existed. Yet I've had standoffs against my own sock account in most chats. And I'm clearly acknowledging that Nick from Phuket Word's reporting process, I didn't know about. I didn't know you could actually report imitation accounts. And I was clearly referencing that in the video that he's aimed at me, claiming that I was pretending that I didn't know sock accounts existed. And I'm like, no, Sean, I'm clearly referring to the reporting process that is clearly new. Why do you think that I'm pretending that these sock accounts don't exist? Are you a moron? The guy's he's just ridiculous.
Yeah, he is. But oh well.
And I'm just checking now to make sure what's the closest place that we can get a 7,000 foot observation, just to see if that were the case, if it's going to change the what we see. Although that would mean that the person's lying, whoever made that website and where they were. But let's just say it is at 7,000 feet, which I think the closest I can get is right about here. So let me try and mark that and see how far that is. Yeah.
By the way, you haven't proved Awake Soul's incorrect with his assertion that you own the website and faked all that evidence on that website.
All Canada evidence has been faked by me. It's all CJ.
Yeah. You haven't proved that it's not true, therefore it's true according to him.
I'm sorry, I can't prove that.
If you don't give him attention, he's just going to keep on saying it. That's what it's all about, isn't it?
Yeah, exactly. His map has never been debunked.
Didn't we have him on our show one time, and he I thought we had a good chat with him, but then what exactly happened with him? I don't get it.
He got sniped by Tim Osman. Remember, that was the day I completely lost it on Tim Osman, and you were on, and John, and you witnessed that, but. And then, of course, he left,
right.
and he claimed that we hired Tim Osman to come on and snipe him.
Does anyone have the curvature calculator up?
Nah.
Yeah, I've got it up.
Okay, can you do a 242-mile observation distance and a height of 7,000 feet, and tell me what the amount of curvature hidden is?
Curvature hidden, 2.46 miles.
Right. So 2.46 miles is, about 13,000 feet?
Mm-hmm.
I can do it in metric. Yeah, 11th imperial. No, it's not giving it. Not giving it in feet. 3.96 kilometers. So,
you said 2.46 miles?
Yeah.
Okay, so I'll just do that real quick just so I can figure out the feet. 2.46 times 5280.
12,900-ish.
Right. So even that is 13,000. Well, that mountain, Canigao, is at its peak 9,500. So you still have 3,500 feet of curvature, and that's if all we saw was the tiniest little tip of Canigao. But we don't. We see a mountain range of various mountain peaks. There's so much. There's over a mile that should be behind the curve. Period.
Yeah.
So even if you go with his belief that we're actually back here observing from 7,000 feet high, or if you go with what they're actually claiming on the site, which is they're down here at this little church, either way. And then if you do the curve calculator for 1,000 feet and observer distance of 175, what does that come out to?
1,000 feet and observer height of 175, did you say?
Mm-hmm.
Miles, right. That will be 2.34 miles hidden, 12,379 feet.
Right, so it's even worse to go with the one he's claiming. Jaron lied. It's actually a lot worse than he says. No, but I mean, it's just funny that obviously I'm going off that website.
In the same sentence, it's equally as bad that he's saying this about you, right? But we have that guy, the guy that you were in the chat with, that's Steve McRae.
Mm-hmm.
One of the comments he's put in the chat was, quote, Person X asserts that P is true. The onus is on Person X to provide evidence. And then he cites somebody that's done something. But fundamentally, if you apply that rule against yourself, let's see the curve, let's see the gravity, let's see the axial rotation, let's see all the things that are missing. You guys don't realize that there are holes in your argument, but you just turn a blind eye to it and just assert it anyway. It's ridiculous.
Let me show an example of that has been going on behind the scenes today. Can you see my screen right now?
Yep.
Yeah.
Okay. So whenever anybody has a private Skype conversation with me, it's not something that I would ever want to reveal or show people. But on the other hand, if you're going to be dishonest and tell some people some things and me something else, well, then I'm going to call you out for it because that's not what you should be doing. But clearly, this is about, I don't know when this was, maybe 2-3 months ago. I sent Kyle, who's the co-host of that show, Non Sequitur Show, I sent him a little video I made that has Elon Musk talking about, we can tell it's real because it looks so fake, and then showing kind of the car rotating and showing that we can see the Earth through it. And I sent him this video and said, if you have 5 or 6 minutes, consider it a personality test, because it kind of asks at the end, are you making excuses in your mind right now why this footage is real, rather than just admitting that it looks completely and totally fake? And he responded, I do indeed. Granted, that is sketchy. And I said, hey, that's a big admission right there. I like you. I don't mind having different beliefs and opinions than other people. In fact, I like it. But if I sent this to 10 Globers right now, like Steve, for example, or Red, the response would have been that I'm an idiot. So maybe you might see why I have the opinions I do. If people can't just look at evidence and at least say what you did, I'm fearful for the future. Then he says, well, I don't believe the Earth is flat. I don't believe we went to the moon. And I think you have to be pretty disingenuous to look at that car in space and say it doesn't look fake. So I said, wait, I read that wrong. Read what you wrote again. I think you made a mistake. You said you don't believe we went to the moon. His response, I don't. The footage on that looks ridiculous. I think if we were in a race with Russia, height of Cold War, we made a decision to make sure we came out on top. So for the last, hold on a second. For the last hour, Steve McRae's been telling me that this was sarcasm. That I'm supposed that Kyle never said that he doesn't believe we went to the moon, that it was sarcastic, and all I need to do is ask Kyle to get the truth. And it's like, this is what these, I said, if you've shamed him into now backtracking on his beliefs, then that's just more evidence of exactly what I think is going on here, is that, here's this guy telling me the truth, that he doesn't believe we went to the moon. But because now that that's public, now he's going to change it, and he's going to say, because I don't know if you guys know, he's the one who made the one question on, that video, 20 questions flat earthers can't answer. He's the one who read the question about how could space agencies be faking space missions, but yet he doesn't believe we went to the moon. So it's just crazy. It's like, this is how dishonest these guys are. So I told Steve, like, I see that as a complete sign of dishonesty on both your parts. And he's sat here for a half hour and tried to explain to me why Kyle does believe we went to the moon. And there's the next page here where I said, hey, oh, wow, that you certainly are not like the others, blah, blah, blah. And he says, yeah, I'm in full agreement. It's healthy to be skeptical. My outlook, he's clearly saying, I even asked for him to look at it again. Are you saying we didn't go to the moon? And again, you're not even allowed to have that belief in today's world. It's not not accepted methodology. Your brain is not working correctly. So Steve has gone into full mode of correcting Kyle.
Yeah,
Kyle, you're not allowed
Steve
exactly what's happened.
Steve McRae's a liar, isn't he?
Yeah. Well, they all are. All of them. All in that
yes.
circle jerk. We do that show. They are all in the same mold.
It certainly seems like that's not being very honest to try and convince me that this guy, he said, oh, I can't believe you took it that way. I can't believe you took it as he doesn't think we went to the moon. I said, I even followed up the question with, wait, read what you wrote again. You made a mistake. You wrote, you don't believe we went to the moon. He says, I don't. So what how, there's no way to read that any other way. And yet Steve is sitting here arguing with me and, well, I guess you don't understand his sarcasm. Like, what? How could you say that's sarcasm?
It's bad.
It's crazy.
Steve asked me before, he said, will you be watching Jeran against, I forgot who he said it was now, but I said no, because the last time Jeran went in there, Red's Rhetoric, that's who it was. And I said no, because the last time he went in there, you, as moderator, you allowed Jeran to get scattergunned approached by Aaron Ra, and that's terrible, because Rumpus does it to us. He'll come in and make 4, 5, 6, 7 points all in the one go, and you've got to work out which one quick fire are you going to address. And if you don't address, you can't address all 5 or 6. You've got to pick the best one, and then he'll just respond to the one that you haven't responded to. And I was like, why would I watch that kind of moderation, which is totally and utterly biased in favor of the ball? All right, Nathan's biased too, but ultimately we're the minority group, right? So we can be biased, but you've got to let you can't moderate a chat and not let Jeran have his fair share of words, and you can't let Aaron Ra. That's ridiculous. There should be a back and forth based on precise, concise discussion, and it just doesn't happen. It didn't happen. It's just ridiculous.
Never going to happen. That's never going to happen in their circle, ever.
And you cannot discuss with a guy who the name is Aaron Ra. Come on, Jeran. I mean,
well, again, that whole thing still bothers me in the fact that they told me it was, oh, this guy wants to have a discussion with you, as if he asked to have a discussion with me. So I was like, oh, I'll have a discussion with him. And then to kind of treat that like a debate where, you have to answer this and you have to answer this, and then back up this claim, and back, like you said, it's like a rapid fire questions where like, okay, I'm not ready for that. That's not what I thought we were here to do. But again, people can believe whatever they want. I don't have a problem with that, but I think we just need to recognize, and I should have recognized, at least in the Aaron Ra, discussion, that what we're saying is completely trashing his entire world belief and view and life's work. I mean, his life's work is to prove that there is no God, that we're all accidental, that the universe is 14 billion years old, and the Earth is 4.54 billion years. That's his goal in life. So when you say something like a flat Earth, which completely flies in the face of all conventional physics understanding, then of course that person is going to fight tooth and nail with it, and they're never going to see. And this is the problem with the whole thing to me, is that when you've got, I think you said earlier, Anthony, you said that when you've got these guys who see what kind of see what kind of attacks come at us, right? How could you be a globe believer and convince yourself that you've been wrong? And I'm not talking about a globe believer like we all were, and we convinced ourselves we were wrong, but we weren't out there on the offensive, yelling across the aisle at how retarded flat earthers are. Once you've done that, I'm not sure you can ever see it, because you look at what's happened with Kyle. I mean, if Kyle said we didn't go to the moon, well, certainly somebody's told him now. If Jaron asks you now, make sure you say you think we did go to the moon, which is just ridiculous. He told me his beliefs, but you're not allowed to have those beliefs. And so that's the same thing for everybody who watches the Non Sequitur show. They kind of intellectually shame you if you ever have dissenting opinions. You're not allowed to have dissenting opinions.
Well, what gets me is, I mean, we know that there are some good points to be had about the flat Earth so-called theory. I mean, there are some good points, and anyone who's a flat earther now had to see that fact and then start researching further to come to this ultimate conclusion, right? But what happens with these professional globe heads is that they will never even admit that there's a single valid point to be had for this flat Earth thing, and that's where I understand or see them as disingenuous shills. But
right.
Well, Aaron Ra, I'm going to make a prediction now that's going to go out a little bit crazy, but I'm going to stand by it, because you know how Werner, is it Werner von Braun? Is that how you pronounce his name? The
Yes.
chief technical. Yeah, you know how he has on his headstone on where he got buried that he has. Is it Psalms
19:1?
Yeah.
And it says something like, "For the heavens show the glory of God, and the firmament show His handiwork."
Mm-hmm.
But Aaron Ra is going to have something similar, because I'm sure that he knows that evolution is nonsense, but he argues it anyway. And all you've got to do is look at like mitosis and meiosis. You see what they call cell division. I mean, have you ever seen cell division, right? You see one piece of like cell, and it doubles, it becomes two, but somehow they call it division. And basically you are watching something that was previously one, now become two, and they call that division. But really, me and you would call that multiplication. We would call creation before your very eyes. You're watching the creation of new cells, and they call that division. He's going to have something like that on his headstone. He's going to say something really biblical, and it's going to look at it, and you're going to go, that guy knew. And we'll all get it. Everybody else will say, yeah, maybe he was a little bit, secretly religious, but we'll all go, yeah, we knew that he knew all along.
I doubt it. I actually think that they are too. I just don't think that they process information like we do. Like normal people can look at an image and say, okay, there's some mirroring happening there, and they will look at it and they will see curvature, and it's never going to change. I don't think they've got the capacity to do that. So I think they're genuinely globe Earth believers, 100%.
Yeah, so do I.
And they're indoctrinated. It's like a religion to them.
And once you're so far sold on it, and of course they give you all the evidence so that you always come to that conclusion if you're just on the surface looking at it, which is what most people do, because by kind of creating this intellectual hierarchy where science believers are considered on one side, and then if you're a conspiracy theorist or you're on the nut job side, well, by doing that they've kind of set up the little structure to where, and then they just need to put out different pieces of evidence that show the globe, and people will always go to that and say this is proof of the globe. It's not proof, again, just because you find Henry's shoe at the murder scene doesn't mean that Henry is guilty of the murder. It's just evidence that that you have to take into account. Well, there's a lot of things that you could consider evidence for the globe Earth, but there is no proof of the globe Earth. There's a lot of evidence for it, but of course they're going to give you evidence in any kind of a deception. They're not going to just and again, you have to recognize this is the biggest deception that there is. You have to understand that, and then from there, Again, are you looking at it with biased eyes? Well, if you were born into that and you were indoctrinated into that, I would say that's one thing. But when you were born into something, indoctrinated into something, you believe something for 35 years, and then you find that you no longer agree with that, that's not being biased. That's now going against the mainstream because you don't see the evidence that should be there. So I think it's totally different, two ends of the spectrum. I would much rather be watching a channel of somebody who every day went out and tried to disprove current beliefs than watch a channel from somebody who was going to go out there every day and simply go to the mainstream evidence and call that evidence. In fact, it's like, no, we know that they put that there. We know that the sun's going to set at 270 west, no matter where you are on Earth on the equinox. We know that. So when Wolfie drives out there and takes a video of that, that's not doing a test. It's not. It's just, you're just reconfirming what the going belief is. And how is that ever going to help humanity move forward? I don't think it does.
Yeah, they remind me of those people in the olden days. Is it phlegmatisms or something that they used to whip themselves? Those radical Catholic people.
Mm-hmm.
They used to walk through the streets and they used to have a whip and they used to whip the backs, chanting religious over and over and over again. This is what it reminds me of the ballers nowadays. This is just how they behave.
Yeah, and it has to become militant, I guess, because the only thing they must consider is that they always say we're lying, as if that made any sense. I mean, it's, or like they say, oh, Jaron's lying about his experiment to show that the Earth is flat. Like, how could anybody have that mindset that would make any sense? Why would I do that? What would be the point? Somebody goes and tries to redo the experiment, and they're going to clearly show that I was wrong. So I mean, it just makes no sense to think that way.
Don't you find it ironic and total irony that they'll criticize pretty much everybody within Flat Earth of being dishonest in some way, yet we're the ones that are here time after time, day after day, week after week, and we stand up, right? But these guys never stand up. You don't find a baller now, the main protagonists, they do not go in Nathan's chat anymore. Why? Maybe it's a protest. Maybe Nathan's too harsh. Maybe it's the wrong time of the month. But they ain't going in Nathan's chat because they know that they're going to get hammered. But they don't accept that it might not be because they might be being dishonest themselves.
But most of them, why don't they use their real name? For the most part, I'm not saying all of them. Yeah, I mean, that's a big sign to me that.
See, to be fair though, that's where I got confused with Sean because he does use his real name and face.
And it's like the same thing.
Yeah, it confuses me that it's like when you look at like a he/she and you can't work out what sex they are. When I look at Sean and I see he shows his real face and I think, maybe he is more sincere. But actually, now I realise the guy's just a moron. So he'd have been better hiding his face so that we could class him as everybody else.
Well, I do think that he's believes in the globe, and that's why they think anything that we're saying. If I show Candigal Mountain and I say it's from 1,000 feet and there should be 13,000 feet hidden and it's only a 9,000 feet mountain, then the default answer for them must be that I'm lying. That can't possibly be the case, and we live on a globe, and they believe 100% that we live on a globe. Therefore, Jaron must be lying. That's just there's no other option for them because it can't be that I'm being honest and that's the actual amount that should be hidden because it doesn't fit with their other belief, which is that the Earth's a globe.
Yeah,
well,
but then how do you?
That was my introduction into the flat Earth, though, with Anthony, because when we did the observation of Blackpool, it all came down to the observer height. And of course, it was my first experiment, so I wasn't really too sure. I was just saying, well, I'm pretty sure I was at this location and I was at this height above sea level. It was an educated guess, which was pretty accurate. But of course, it came down to them continually baiting us, wasn't it, Anthony, about the observer height.
If you're going to credit Sean with the honest belief that he lives on a ball, okay, well, what about the malfunction that he's got, which is the inability to cite people in context or accurately ever? I mean, surely if you're going to be intellectually honest, he honestly believes that he lives on a ball. Why
I didn't say he was intellectually honest. I certainly didn't say that.
No, but if he honestly believes that he lives on a ball, that is his intellectually honest position. But what's the explanation for why he can't cite people in context ever? He never gets it right. But no baller ever says, "Hey, Sean, come on, you got this wrong here. The least you can do is pull down the video." But he leaves the video up showing Phuket word, and I'm like, Sean, that's totally dishonest. So even if you honestly believe that we live on a ball, you can't credit the guy with intellectual honesty with regards to his citation skills because they are naff.
No, they're bad. And again, their narrative doesn't even make sense. On one end, it's I'm faking experiments, and the other end, it's I'm purposely not showing them to my subscribers. Then I do a live stream from the place that they're doing the test, and I was trying to hide it, and it's all over the place. It doesn't make any sense. But you're right, nobody calls them out for it. So
No.
the people watching that channel are going to be people that believe what he believes, and so whatever they say about me, I've seen him do a 3.5 hour show, a hangout on my belief of what the size of the Earth is, and they made up the size of the belief. They came up with it themselves. They just took the equator and like doubled it, and then figured out what the circumference of said circle would be, and said that's what I believe is the circumference of the Earth and how big. I said I've never said any of that, but they did a 3.5 hour hangout on my belief of that exact thing that I've never claimed.
He did the exact same thing with me. He took something that I said and changed the context. Words were similar, not exact, but similar. Changed the context, and then had a 3 hour hangout based on a misrepresentation. And I was like, "That isn't even what I said, you moron."
Yeah,
it's so bad.
It is bad because there is a lot of things that, again, they come right to you and say, "Hey, this is proof that the Earth's a globe." Like, for instance, this Antarctic little cup race that they did. That they went around Antarctica.
Yeah.
And when you look into the details of that you can look at the type of boat that they're using and everything. And that boat, if you go elsewhere, get away from the Antarctic test, go look at this boat up and look at how fast it goes, and it's like 20 or 30 knots is its top speed. Then go down and look at the speed that this boat supposedly went around Antarctica, and the boat's going like 4 knots the whole time. And it's like, I can just look at that and say, well, look, if they didn't know how far they were actually going, maybe they were moving much faster than 4 knots, but according to their logs, it's going to look like they were moving 4 knots. And they'll just go crazy and say that's not physically possible. It's not possible that these people on the boats wouldn't recognize that. It's like, well, then you're not looking for ways that we can be fooled, because it'd be very easy. Nobody's out there mapping the oceans. It's just not what happens. It's not the way it works.
Yeah, MH370 went missing and never got found, apparently, and the answer for that would be logically because GPS doesn't cover the oceans, but that's assuming that the plane even went missing in the first place. But let's just assume it did. The reason why they couldn't find it is because the oceans are not mapped.
Yeah, I think that it was real. Again, when you look at whether an event is a hoax or not, you tend to look at what good would have come of that. Well, the last thing they wanted to let people know in the world is that they don't have GPS coverage on planes in the South. So certainly it was not beneficial for this story to come out in any way. So I tend to look at it as a real story. And you're right. I think that if there's certain sections of the ocean that are not part of GPS, people would never know. The plane could crash there and nobody would ever find it. And I showed on my live show not very long ago that I said, what kind of things would we see if that was the case? We would see boats go missing. And sure enough, in the hunt for the MH370, there's a boat that was missing for 3 days. And they tried to interview him and say, where were you guys? And they said, we were just over here. But that they were probably in a part of water where it wasn't tracked.
How many times do you see ghost boats turning up at like 6 years after they went missing, and the guy's still on board and he's died whilst he's been out navigating, and he's got a broken mast and his boat's still floating, but 6 years it's been missing. Nobody knows where the boat is, and it turns up on the shores of, I don't know, Taiwan or wherever. These ghost boats do turn up, and that should never happen if we have this GPS coverage of the oceans. It shouldn't. You should know exactly where every single boat is.
Yep, I've tried to show before. Take a piece of paper and wrap it on a ball, and you're going to have extra paper.
Excess.
So
Yeah.
if you knew the land layout of the Earth, or at least this section of it, and you were to map it on a ball, you would right away know you have to get rid of some, and you couldn't get rid of land because people would notice that. So you have to get rid of water. You would just cut out parts of the ocean, and you would wrap it on a ball, and then you've got all your distances across said oceans, and there would be signs of that, like flight times and things like that, which we see. Add in the jet streams, and you've, again, that Sydney to Santiago flight that everyone talks about. If you figure out what their speed is and you look at the jet stream, which they've taken the site down where we used to get that information, being at Earth.Null School, but that jet stream could go at times 250 miles per hour. And when you figure out how fast the flight was going, it's going like 525. So if that's the truth, then you have to really look at it and say, well, it's 525 minus the 250 or 525 plus the 250, because either they're going, what would that be? 375 or whatever, even 275, right? Yeah. Either they're going 275 and just riding the jet stream to get the total of 525 per hour, or they're going 525 and getting an extra 250, in which case they're going 775. And then you multiply that by the 14-hour trip or the 12-hour trip. And all of a sudden you've got 2,000 extra miles that plane could be traveling that nobody would know. You just wouldn't know it.
No, worse than that. Sorry, one last thing. You have Wolfie 6020 telling everybody that WGS 84 is like this lattice that overlays the Earth perfectly because it's a sphere. And I'm like, yeah, but that could equally be unravel the sphere and then put it on a flat plane. And then you believe that you're traveling over sphere, but really it's flat. But you don't know all the areas that are not covered by that WGS 84 because you believe and told and trained that it works perfectly. And the reality is it could be over any shape Earth whatsoever. But if you're told it's a sphere, then it's always going to work out because it's an overlay.
Right. And they think that GPS is proof that we live on a sphere because it works on the sphere. So they don't get it. They just can't. No. And I think it's like a different brain functionality to where you don't have to defer everything you believe to others, which is how we think. Whereas I want to hear input from others. I want to hear people tell me their ideas. And from that, I'll base my my solid belief upon that. But I certainly do not base my solid beliefs on what does the mainstream tell me I have to believe that. And that's what they believe. If GPS is done on a sphere, then it means that it had to have been done on a sphere and there's nothing else. There's people who think that way because that's what's told to us, I guess. But yeah, the WGS 84 is like you said, it could be done on a flat map and then wrapped on a ball. And then it's going to tell you your global positioning. It's going to tell you where you would be if you lived on a globe. That's what it's going to tell you. And then think of how much miles they could have played with when you really think about the difference of a flat ground versus a curved ground, being that from the North to South Pole on a globe would take you 12,500 miles. But really from the North Pole to the South Pole, if you're just drawing a line straight through it as the diameter would be 8,000. So right there, you're talking about 4,500 miles that is kind of they can play with it. Because if it's flat and you're not going over a curve, then all the distances that we know between land is always figured out as if you're going over curvature, but you're not. So there's actually numbers, they could fudge numbers wherever they want and kind of get it to be whatever they need it to be. And it's been constantly changing forever.
Yep. All right. Cool. Well, that's cool. That went off into a great discussion, honestly. But we are, of course, at about 3.5 hours now, so we probably need to wrap it up. I do want to mention just a couple other things really quick before we take our last round. But as many of you have seen, I have been kind of flashing our FE Core's newest toy, which was really expensive, but we managed to get it financed anyway. And with Mike and his salesmanship, he actually got Ubiquity to knock off a very, very large percentage of the price in exchange, of course, for some promotional, mentions and stuff. But what I wanted to say is, and we talked about this, is FE Core is going to be doing a 91.3 mile microwave and laser test simultaneously from the coast of the Netherlands to the UK. And what is that? The Cliffs of Dover? Is that what that is? The White Cliffs, Tony? Or Renty, either one? I think that's right.
Yes, the White Cliffs of Dover.
Right. Okay, so they're going to be firing the laser, and of course the White Cliffs of Dover give us a beautiful backdrop to be able to hit with the laser, and simultaneously we will be running this microwave test, at the same time. But we will be doing it from a considerably lower location than what should be provided, for curvature. And the curvature is something like 5,500 feet of curvature that we would be dealing with. Of course, they already set a record of 189 miles. We're basically going for half that. But the difference is we're going to get this sucker down as close to the ground as we possibly can and see how long we can keep it reliable. So this is going to be kind of a double whammy for the globe. Not only should laser light not be able to transmit across that distance, but neither should a microwave. And we intend to prove that not only will the laser do that, but so will the microwave. And the microwave will be set up so that it has a reliable data stream so that we're not being affected by violating the Fresnel zone and, having multipath condition. All of that stuff is basically, geared around a ball earth curvature, which we are asserting is not there. And therefore, that is exactly why we're going to be able to get our microwave link across that distance, as well as our laser shot. So that's something to look forward to. It's we did receive the equipment as I just showed earlier. Here we have a picture of Mike Kavanaugh with one of the main dishes here, and like I said, it's just top-notch equipment. And the other thing is we've kind of got just a little pan around here that shows it sitting on a table. We've hooked it up, calibrated it. It works perfectly, and the first test is going to be done, I believe, across Lake Issel, or the one that's by Mike's house. That they're going to test it there, and then they're actually going to do the Cliffs of Dover. So, again, ball earthers, this is us putting our money where our mouth is, doing the experiments, and of course, everything will be shared, videotaped, and provided, for everybody's scrutinization. We have some fabulous MEMS device experiments coming up, IMUs. Like I said, fortunately, we have been able to start working with a retired Boeing engineer who is an expert in this field and has been kind of guiding us along, which is kind of neat. But suffice it to say, guys, there's a lot of people out there that are closet flat earthers that, because of this ridiculous stigma on flat earth, they don't dare, show their face for fear of losing their job.
created this.
Whoops. What was that? All right.
Sorry,
Well-
that might have been me. Can I ask a question?
Sure, certainly.
The ballers are obviously going to come back with refraction as the excuse if this works. How would refraction work or not work in this? Could you just address refraction?
Well, refraction is going to be more of an optical property. When you're dealing with microwave signals, the main thing you have to be concerned about with is the Fresnel zone, and basically that is an area where the microwave could technically be susceptible to what's called a multipath condition. Okay, and essentially what that is it could either go up and duct through the atmosphere, or it could go down and bounce off of the ocean water. And what will happen when you get into a multipath condition is you will have the signal, the primary carrier waves, arriving at the receiver side at different time intervals. And of course, if you know anything about digital signals and how they are synchronized, you cannot have things arriving at different time intervals, because if you do, you will get checksum errors and you will get constant, requests for resends of packets. It'll just be a mess, essentially. So that's the idea of, if there was anything akin to refraction, that means that there would be a heavy distortion in the digital stream. Now, and of course, we can see that by the level of checksum errors that we get, and that's simple data diagnostics that we can actually look at it with. So really, they're not going to have much of a leg to stand on, because any RF engineers knows that this particular test is pretty bulletproof. And like I said, we've talked about this. I've talked about this several times because I used to work for a company called Western Telecommunications as a field engineer. And I actually wrote all the software that did all the automated testing. I was out there actually setting these things up and calibrating them, setting up the redundant receiver arrays, making sure that everything was absolutely to specifications. And when I tell you that, we had a typical length or a shot of about 60 miles in between some of these sites, that's pretty normal. But we would also occasionally bypass certain links along the chain, and we would point something to a site, 2 sites down, and align the dish. And we're going well over 100 miles. And, when you're talking about 100 miles, you're talking about almost 7,000 foot of curvature. And we were doing well over that. And I think Robin Poe also used to do that in the military. But, 100, 110, 120, 130 miles, no problem, no checksum errors, nothing like that. And, so I know it can be done. I've seen it done. And we're just going to do it again for the record this time. So, if there was anything like refraction or anything that would cause any type of analog, where you get this visual distortion, how that would be translated in a data stream is in checksum errors, and the data stream would be completely unusable. So the ballers can claim stuff like that, but the fact that we would be getting a solid data stream would annihilate that argument. So hopefully that answers your question, Tony.
It certainly does. I didn't know. I mean, I read that microwaves are part of the light spectrum, therefore are subject to only gravitational refraction, but not optical refraction. But the gravitational refraction is basically that small that it's not even worth talking about. In other words, there is no refraction. And if that's the case, then that would be the response I thought you were going to say. But if there's more checksums to do with the continuity, the stability or the credibility of the actual data that's being sent and received, then I don't suppose there would be any refraction whatsoever, right?
Nope, not really. And like I said, we're going to put that to the test ultimately by allowing it to run through all different types of weather conditions. You know, we want it to be cold, we want it to be hot, we want it to be raining. It'd be great if it was snowing. I mean, everything that we could possibly get it through, you know, within whatever restrictions we have as far as being able to set this up. We're going to, you know, put it through the gamut, you know, just literally everything that we can do to try and make it fail, and then document meticulously when and how that happens and under what conditions. So there you have it. So, okay, so that's about the only other thing that I had. Well, actually, I had one other thing. And this is crazy. And guys, I would suggest that if you haven't heard about this, that really we need to get on Android's butt and Apple Store's butt and get this app taken down. But there's a new application that's called Sniper something. Anyway, I'll look at it here. Oh, here it is, Sniper Shooter. Okay. And basically, what this is about, and this is the level of desperation that the ballers are going to. I mean, it isn't enough because their ridicule isn't working, but now, and neither is their censorship. But now, what they're trying to do is they're trying to make it okay to put out these first-person shooter games where they are advocating killing flat earthers. Straight up, no, I kid you not. The one on this one that is on the Apple app has 48.9 thousand 5-star ratings. They don't say how many times it's been downloaded, but the one on Android has over 10 million downloads, and it's rated a 5-star game. Now this is just over the top, guys. You know, when this is the level that they are stooping to, and when all we are doing is doing experiments, asking questions, and questioning NASA, heaven forbid you question NASA and their lies, now they are releasing these games where they're literally promoting the idea that flat earthers be shot and killed.
If you twist it on its head,
yeah.
If you twist it on its head,
I killed
imagine
4 flat earthers.
Just twist it on its head for a minute and imagine that a flat earther made this video and
I
put in
killed
it
6.
like Neil deGrasse Tyson or Brian Cox. Do you think that would last more than 2 minutes online?
Not a chance.
No way.
And it shouldn't be allowed online now because it's advocating assassination of people that have different belief systems. You know,
But it's a group of people. It's attacking a group of people.
Yeah, you can't do this towards the Church of Satan, right? I mean, they would completely take it down if it was for that. But you know, flat earthers doing this investigation. Oh yeah, it's great for that.
Yeah, but the problem is we'd have to class ourselves as a religion for this to apply in our favor. If we denounce the religious aspect of it, then they'll say, well, you're not a religion, you don't need protecting, right?
Yeah, well, yeah, whatever. You know, a lot of people say I'm a veteran and I'm proud of it because even though I may not agree with things that people say, I have fought to defend that right. And I, as a veteran, even though I have never seen combat, I was in during peacetime. Nevertheless, I was ready to take that risk, right? And it's just completely wrong. I mean, you have to accept the idea. If you're going to accept the idea of free speech, then you even have to get behind defending somebody as stupid as Awake Souls and a vet skeptic, that to be able to spill their rhetoric out there, that because they have that right, okay? Even though we don't agree with it, they have that right. But these people advocating this because of our research and things, they don't have that right, and this is wrong. And honestly, I think we should start a class action suit on this. But at the very least, we should be, going after these guys and saying, hey, what is this? This is pure and simple, promotion of hate and violence, and it's just
Minority
wrong.
bashing. It's minority bashing. That's what it is.
Yeah,
Yeah,
and
but,
it's wrong.
we're not a protected minority because we're not classed as a religion. We're not classed as the groups that gay or lesbians. The groups that are protected, we're not one of them groups. So I think they'll probably allow it because we're not one of them groups. Maybe.
Well, let's see
I
what
don't
the
know.
snowflakes say now then, because they should be all up in arms over this.
Yeah. Well, I certainly am. I think it's wrong, and I think that
Yeah, I
this
agree.
this is about as lower than a snake's belly, honestly, to even allow this kind of idea. And one of them, one of the omissions here is, they're talking about, here's the guy, Fred the teacher. All town kids think the earth is flat thanks to this guy. He bought his diploma on the internet. Yeah, right. That's how he became a teacher. Objective, fire him. Literally, he'll be on school tour with his class, right? Oh,
There is another way we could view this. We could demand that we could have an edit function so that we could adopt it and we could put all our names into it and we could all take, like we did with Belu. We adopted the Belu stance. Well, we could just adopt it and then they can't use it against us, and we could all be on there as like our own celebs in our own right and just adopt it, and therefore it becomes ours, not theirs.
yeah. Yeah, well,
I like it.
yeah, I like that.
I want first dibs at Iru.
Yeah.
Okay.
Line Gerald.
Try it.
We need a big clip.
You must be having, but this game, for example, this game has in consideration the Coriolis effects when you're shooting or not?
It does.
No.
Of course.
No, because if we're going to make a simulation to shoot,
Oh, we'll be safe. We'll be pretty safe if they're playing it in a washing machine.
Yeah, it's crazy. Well,
But talking in terms of game, I have like four or five piece of videos that there is a lot of game where the main character is, I don't know, walking on the room and he's enter onto the room and a boys start talking about flat earthers, and I talking about esports games. I'm not talking about like this one which is a regular game. I'm talking about production level game talking about flat earth. I don't know if you saw some of those videos.
no.
Okay, let me just find it. If you want to continue, please.
Okay. Yeah. Well, we're wrapping up, so you really can't do anything else. But we can get to that next week for sure. But,
okay, you are turning Jeran place. Okay.
Okay. I'm sorry, I missed that. Say that again, Eric.
No, you are starting to convert into the Jeran, whatever. Forget about it.
Okay. All right. Now I understand what you're saying. I'm sorry.
I still want to know who Sharon is. That's my.
Yeah, that is why I'm shut up myself, because I know that I pronounce.
Hey,
can I call you with another name? Like
you can call me
Antonio.
Yeah, call me that.
Antonio.
Okay, perfect.
Yeah, I can't speak five other words of another language, so I'm.
Well, your English is way better than my Spanish. Just
right,
saying.
exactly.
Yeah. Well, the only good thing that we have is if the ballers are using, calculating for Coriolis effect, they're never going to hit us. So that's a good thing, right?
That's a good thing.
I just hide behind the curvature all the time.
Yeah, that's it.
Behind the hump of water.
So yeah. So I guess one last thing, and I suppose might as well. We'll end this on a happy note, which is funny. But Robbie, Celebrate Truth, found a video, and CBS actually did a report on this. And this is the kind of scientism BS nonsense that we have to put up with, constantly. But basically, apparently, there's this big study that's been done, and scientists have now discovered that we have a second brain, and it is located in our butt. Okay,
What?
and they are quite serious about this. And I saw this. And,
Is this for the Globelings? Is this where their brain is?
Yeah, it must be. Well, when I saw this, my first thought was, and I left this comment there. Wow, if that's true, Kim Kardashian must be a genius.
And I guess asshat is a compliment.
Exactly. Yes, and it gives a whole new meaning for to shit for brains. So there you have it.
and awake assholes.
Yep. So with that, let's go ahead and take it around for one last thing, and we'll get out of here. So, Sleeping Warrior, Tony, what do you got coming up?
I don't know what I've got coming up, but what I will remind people is that anytime that anybody used any curve calculator, if you're going to apply it against a target, don't apply it against the absolute height, because things in distance do appear to get smaller. So just reduce it down to about 25 pixels and then apply the curve, and then all of a sudden that stuff's gone. So don't apply the absolute height, apply the relative height, and until they tell us what the maths is supposed to be, we'll guess, because really it's their calculator, it's their maths. We'll just put it in at 25 pixels.
Well, there you have it. Okay.
Well, and there is a predictable sort of algorithm you can use for perspective, but when you get to the distance, it's like a mountain range, a couple hundred miles away. What do you have to base that on, right?
Yeah, sure, but the problem is it's not our claim, is it? It's their claim.
What was that? Sorry.
It's not our claim.
Right.
It's their
Yep.
claim. Yep.
So until they tell us what we should do, then we should just kind of just apply it anyway and let them correct it, and then we'll check what they tell us is the correction, and then see how does it match reality or not.
Yeah. Okay. All right. Beautiful. So, Ranty, we'll go ahead and move ahead to you then. And do you have anything coming up, or any more experiments that you're going to be doing, or what's on the horizon for you?
I will. I'll be certainly doing more experiments around this far coast. I'll go every day like I have done for the past 3 months or so. And hopefully I can see something south, because for whatever reason, every time I seem to try and look to the south, it's very, very hazy or unclear, and I can't even see the Welsh mountains for the most part. And they should be clearly visible at all times, but it's just like a whitewash. But when I look north, obviously through Barrow, that's when I get all my footage. But I've also been to Hoy Lake a couple of times, and I've seen some fantastic proofs for there as well. So I'll probably be releasing them in the next couple of days.
Okay, beautiful. Oh, look forward to seeing that. That'll be great. Awesome. And so, coming around to you, John, what do you got coming up?
I got a bunch of new stuff on my channel, so everyone make sure and check out the Morgile channel and subscribe or resubscribe, and always new stuff on the way. So yeah, awesome hangout though.
Okay, yeah, beautiful. I really enjoyed it. It was great. And so we'll move on to Iro. And Iro, if you really want to show that clip, feel free. You can. I was just giving you a hard time, but
No, it's okay. It's okay. I understand.
okay.
No, I didn't find it. Because if I would find it, I'm going to, sabotage the show, and I'm going to start share my screen, whatever. No, I didn't find it. I think I have in my other computer that I unplugged for having a good streaming. But no, I planning to do. I'm finished. I'm like I say, the other show, I trying to make more English content, but I didn't have the time. I'm starting to put my hands on the motion graphic for the Flat Earth conference on Denver, so I'm gonna be a little busy with that. And but I keep going to making my Spanish content. So I hope you wanna, one day you start know how the Spanish language works, and we can share that content.
Okay, fair
It's
enough.
more easy. It's more easy that you start learning Spanish than I make my English video, I think.
Oh, I don't know. I think you do good on your English. Oh, hey, by the way,
Yo necesito mucho perico.
oh, there you
Bueno,
go.
está bien.
So,
Perico? Coca-
No, never. The Perico is like say parrot.
the parrot. Okay.
Yeah.
So, just out of curiosity here, I mean, you've done some things, some work with Oliver Ibanez. Do you think he would ever be open to coming on the show and kind of doing
Yeah,
a
I
presentation
can.
in English with you guys? With us guys, I
Yes.
mean.
Yeah, I can talk with him and ask him, because I don't know if he is he's a lawyer also, and I don't know if he is, feeling good making live presentations, because in his channel he's more make it, short videos, pre-planning videos, because he was invited to the Flat Earth UK convention, and he didn't. I think, I don't know if was something about the time that he have, because he's working also on that kind of stuff. But I can ask him. Maybe he have something to present live. I mean, if you enter to his channel, he never make that kind of shows that like we did. He is more than, uploading videos shortly, short videos, but he never make something in real time with the presentation. He make, I think, 2 or 3 hangouts, but just for asking question from his subscribers. So I can ask him. Maybe he can prepare something.
Yeah. Okay. Well, that's cool. I mean, you would think that an attorney would be used to making presentations, but who knows? So okay, well
Okay.
that would be cool. It just I just thought that not many people know of his work, and I know he's very popular in the Spanish speaking
Yes,
places too.
he did something really great, because he start a tweet fight, quote fight, but he start to tweet directly with an astronaut, with Peter Duke. So he start become very popular based on that discussion, and of course this astronaut never answer straight. Then he never make a straight answer. So that is why he comes so popular.
Okay, cool. All right. Well, we'll see what we can work out on that then. I think that'd be awesome. So
Okay.
Oh,
all
can I
right.
just say one last thing?
Sure, Auntie, go ahead.
Yeah, don't forget to subscribe to my channel if you haven't done so already. It's Ranty Flat Earth, and you have to actually search for the channel, because for some reason I don't appear at the top few things. So that's Ranty Flat Earth.
Okay, and if you guys can't find it, both Ranty's and Tony's channel are already in the show notes. You can go there, and of course they will remain there as well. So there you have it. Definitely subscribe to them, and they're both doing some really, really good work. All right, and last but not least, that brings us to you, Jaron. What's going on?
Not a whole lot. I do have a video that'll be coming out the second that we finish this hangout, so you can pop over to my channel, and it's just another Friday night date parody musical by my wife and I. So enjoy that. That's to the song. Have you heard Havana by Camila Cabello?
I haven't, or maybe I have. I don't know. I don't recognize the title, but I'm sure it'll
be good. It's a song called
Havana.
Yeah, it's a good one. So we did that Friday night, and it's done. So it's uploaded, just ready to hit publish.
Okay, cool. Sounds good. All right. Well, I think that's it. And yeah, don't forget, Jaron. Of course, we are stopping our own streams this time. So get your finger on the trigger there.
Okay, ready?
And yeah. So we're almost there. So, all right, guys. Well, thanks for joining it this week. Sorry it was another long show, but we got a lot of good stuff covered with perspective, and Ranty and Anthony Riley will definitely be back.
And it's done. So it's uploaded. Just
whoops,
that was my fault.
Okay, no problem.
Just trying to get over to that page to do it.
Quiet. All right. Anyway, so yeah, I'm sure you guys are definitely welcome to come back and join us, and show us any new evidence that you have. Always looking for that stuff, and I think the perspective subject is going to be hot for a while yet. So I'll be looking forward to seeing future stuff. So anyway, guys, thanks for joining us. Mods, thanks for keeping the peace in the chat rooms, and we will see you guys next week. And until then, be good to each other. Don't lie to each other. Open your mind. There's truth inside. Peace out, everybody.
Peace.
Peace.
Peace.